Morning, everyone. Good morning. We're going to start kicking this off about 10 minutes. So make your way in, get to the comfortable seats up on the top. Over about 10 minutes, we'll get it going.
Off, green is on.
We got about 2 minutes. If we go ahead and get ready, take our seats, and we'll get kicking off here shortly. About 2 minutes. Morning, everyone. If everyone could silence their cell phones. That was a short 2 minutes. Howdy, everyone. Welcome to Austin. We're glad to see you guys on behalf of Army Futures Command and Army Applications Lab. Welcome to Austin, and it's good to see everyone here this morning. I recognize a couple of faces in the crowd. So my name is Sam Spencer-Pittman. I'm the Director of Corporate Ventures at Army Applications Laboratory. You've either met with myself when you're a company trying to get business with the Army. You met with my counterpart, Valerie Vernetti, over there, and then Ari Kane. He's probably speaker wrangling somewhere over there in a black vest. But welcome. Glad to have everyone here this morning. Real quick, just a show of hands, real curious. On Friday, who tried to watch that Mike Tyson fight on Netflix? Who was plagued by glitches and buffering? So VERTEX comes at an opportune time because information in the tactical network is what we're getting after these next 2 days, and we are glad to have experts from industry here in your companies with data, communications, signal, everything to help us out to get after the Army problem sets that we need solutions and ideas from each of you. So before we get things going, I'll give you a little instructions on housekeeping rules. You got the back exit. There's the door. If something happens, go out the back door. If not, break glass and beeline left or we're going to have the social this evening across the street at Hegbe's. When we get this morning, you're going to have a duo keynote speaking event. And then we're going to have 2 panels moderated by some soldiers and then others from experts in industry. And then we'll give you guys a 2-hour lunch break. And then in the afternoon, you're going to do breakout session on the 8th and the 1st floor. The breakout sessions will be in here, around the corner, past the bar, the kitchen right here, and then on the 8th floor. And you'll have representatives from Army Application Lab guiding you through. But we're really excited to have everyone here this morning. And without further ado, before I kick off to our executive director, the bathrooms, if you haven't found them, right down outside these doors, beeline right, past the elevators, you'll see the bathrooms. If there's any security issues anyone's worried about, next to the elevators right over here, there's security right there. Or find me, find Valerie, find somebody with Army Applications Lab or Army Futures Command, and we'll take care of it. But without any further ado, I'd like to introduce you to our Executive Director of Army Applications Lab, Dr. Casey Purley.
Thank you. Good morning, everybody. Happy Tuesday. First of all, for those of you standing in the back, there are seats up front, scattered throughout, if anybody wants to sit as opposed to stand. All right. So, welcome to VERTEX Tactical Innovation Network. We are so excited that y'all took time out of your schedules to come here and participate. I am thrilled to see so many organizations and interests represented here. From the government side, we're really fortunate to have a wide variety of stakeholders from across the military, including 1st Cavalry Division, 4th Infantry Division, 82nd Airborne, and the 101st Airborne Division, 3 Corps and 18th Corps, as well as some of our allied partners. We also have the U.S. Special Operations Command, Joint Communications Unit, Army Test and Evaluation Command, partners from our labs and centers, our cross-functional teams, so Future Vertical Lift, All Domain Sensing, Command and Control, PEO soldiers, so these are people that buy things, and the requirements writers from our Aviation, Cyber, and Fires Capability Development Integration Directorate, so CDIDs as we call them. My point is to show you that there are a lot of subject matter experts here from the government that are really interested in sharing their perspectives, especially if they're soldiers, and taking all the feedback that you give us to help us rethink and reframe these problems we're talking about today. So Army Application Lab is Army Futures Command's innovation organization. Our mission is to get the best technology into the hands of warfighters as quickly as possible. And lots of those organizations that I just mentioned share that same mission. Our niche is that we exist to expand our Army's access to our civil innovation base, namely non-traditional industry. So for our government partners in the room, that means that AAL can help connect you with the best technologists in the world that you might have never heard of. One of the reasons that it's so important to engage non-traditional industry is that the innovative potential of industry and academia is a real strategic advantage that the US and its allies have over our near-peer competitors like Russia and China. But we can't do this the same way we did it 60 years ago. So 60 years ago, over 2/3 of R&D spending in this country was government funded. Today, it is 20% and continuing to decline. Commercial industry is leading the way in technologies the military needs, from AI to robotics to cyber and network. And that means we need to work with companies we historically haven't. And we need the incentive structure to be right for y'all to want to work with us. We know that it is hard to do business with the DoD, and even just figuring out who to talk to about opportunities is hard. So you can be a company that's already on contract and still have trouble figuring out how to get paid or how to navigate authorities or certification processes. Now, while improving companies' experience in working with the DoD is part of AAL's goal, we're really doing that in search of that higher purpose, which is to get the best solutions to the right problems. Now, at Vertex, we talk about problems and solutions. So soldiers, requirements writers, and companies who each solve different parts of the problem, and the acquisition team who could ultimately field the technology are face to face. And out of these discussions can come the realization that the solution might be radically different than what the Army thought it would be, or that we might be trying to solve the wrong problem altogether. A requirements writer might discover that they were writing requirement for X when maybe it should have been Y, and a company might realize they were offering the Army A when really we didn't need A, we probably need B. But we can't figure that out with any kind of speed if we're just communicating through RFIs on sam.gov. So that's why it's really important to get all the people with the right perspectives here in the same circle. In September, AAL, along with our collaborators at the Next Gen Command and Control team, we went out to Fort Cavazos and we talked with soldiers from 3 Corps, 1st Cavalry Division, 1st Armored Division, 7th Infantry Division, and the 101st Airborne. They shared their experiences and frustrations with the current network. As you'll hear from the soldiers themselves on our first panel, a lot of these frustrations center around how to get the right data to the right person quickly without having to physically swivel between systems and without having to search through the mundane to find the important. So why did we choose to focus on the Army network for this Vertex event? Well, it is the Chief of Staff of the Army's #1 priority for Army transformation. And if you can't communicate, nothing else really matters. The technologies that are going to solve this problem for the Army are the ones that are developing most rapidly in the commercial space. But the Army is unique because we don't send our Army places where its systems can ride off of established, stable infrastructure. Now, before I turn it over to Colonel Kalustian and Colonel Skaggs, who lead the Army's Next Generation Command and Control team, and who will tell you far more about this incredibly complex problem, I wanted to leave you guys with some of the results of our past Vertex events. In July of 2023, we hosted Vertex Robotics. Much like today, representatives from across government and industry gathered in this space. Vertex Robotics was informed by a Forge, or Army Innovation Network event at Fort Liberty, and we worked with the Next Generation Combat Vehicle Cross-Functional Team, the Ground Vehicle Systems Center, and others to develop the use cases to support those breakouts. Requirements writers and concept developers were all ears. And based on the information we learned from industry, we released a solicitation on remote breaching. By the end of January, we already had 7 companies on contract, and we kicked off the project at Fort Liberty in North Carolina. Not only were our requirements writers better informed on how to state the problem, when proposals came in, we had a much deeper understanding of what the market had to offer. Those 7 companies have been down selected to 3, and they will have their midpoint demonstration at an Army experiment in May. Another solicitation informed by that event on shaping terrain in front of the forward line of troops is on a similar schedule and will kick off its minimum viable product build Thursday. In February of 2024 and July of 2024, we hosted VERTEX Contested Logistics and VERTEX Air Ground Littoral, respectively. A solicitation coming out of that VERTEX Contested Logistics event is going to be released the first week in December, and one in support of VERTEX Air Ground Littoral is coming early in the new year. VERTEX is just one part of our continuing effort at AAL to help bridge the valley of death for companies. If you want to be part of our other work, please follow us on LinkedIn to learn about open solicitations, or scan the QR codes to join our network or sign up for office hours with the AAL team. To the Army and the government folks here, I hope all of you keep supporting the work of AAL and bringing us your battlefield problems to work with us to create solutions. To the people here from industry, thank you for bringing your perspectives and your innovations to VERTEX. We are excited to learn more about you and your technology and to gain insights that will help inform how we solve some of the Army's most complex problems. I hope over the next 2 days you are able to meet and connect with each other, because some of the most interesting solutions come from the most unexpected connections. I now have the honor of introducing our next keynote speakers. So Colonel Matthew Skaggs leads the Next Generation Command and Control Team for Army Futures Command. Colonel Skaggs entered the Army in 1993 as an armored crewman in the Idaho National Guard and was commissioned as a first lieutenant in 1997. He has served as the unit's senior intelligence officer from battalion to a 3-star Joint Special Operations Task Force, and his most recent assignment was as the JSOC J2, which is the senior intelligence officer for the Joint Special Operations Command. Colonel Kalustian received his commission into the U.S. Army Signal Corps through Old Dominion's ROTC program in 1998. His 26-year career has spanned a variety of Army and Special Operation Command assignments. He has most recently served as the Deputy G6 for U.S. Army Europe and Africa, and is the commander of the 2nd Theater Signal Brigade in Wiesbaden, Germany. Other assignments include the J6 Director of Communications for Special Operations Command Central, being the commander of the 51st Expeditionary Signal Battalion, and a Signal Squadron commander for a Special Missions Unit. So please welcome Colonel Skaggs and Colonel Kalustian to the stage.
Thank you.
You're up.
Thank you, Casey.
Thank you.
Everybody hear me? Good morning. I'm Matt Skaggs, and this is Mike Kalustian. We're partners in this effort, as Casey mentioned. The reason I'm standing up here today is basically 25 years of aggravation of the Mission Command Systems. I've starting, and you heard my bio, as a 19-kilo tank crewman, moving up to an intel guy. In the old days, we had plexiglass boards with maps in them, and we drew on them with red pens, or we sat in the command post with a big, huge map board and listen to our FM radios, freaking magic radios, and we put push pins in there. And everybody knew where the enemy was, and everybody knew where their friendly forces were, and the analog thing worked. We didn't have to worry about communicating with other command posts. We talked about it over the radio, and sometimes the SIGOs would get yelled at if the radios didn't work, but we knew what was happening. Felt pretty good with it. But the reason I said that 24 years of aggravation is that, in my mind, the aggravation started with the advent of the Force 21 unit of 4th Infantry Division. We called it the Star Wars unit at the time. We're going to make everything better. We're going to put digital mission command systems in the command post, and we're going to be able to see all the data and pass all the data, and we were going to be ready to take everybody on. But when we started there, every different warfighting function got the tasker, hey, make a box, put data in it, and we'll be better. And so the artillery guys made a FATAS, my tribe made ASAS. Some guy came in and gave us CPOF. Nobody was really sure where the command post of the future came from, but we had it. We had AMDUs and TAEUS, and we were ready to take the world on. And so fast forward a year, and I'm crossing the LD for what we now know as the Great Patriotic War in Iraq. And I had an FBCB2 in my truck as a company commander, and you know what I could see? Nothing. I saw my icon, and I saw a map, and I wasn't totally sure it was right, but we were on what was the forerunner of a mesh network on EPLARS, and it never worked. We got CPOF, and we saw some dots, but that's not all the things that were supposed to happen. And the problem is when we got the taskers for the Force 21 days, we had everybody build their box, everybody do data ingest. Everybody moved out, got a box, did data ingest. Everything went to their own data model, but none of those things could talk. I said before I was on ASAS, All Source Analysis System, the forerunner to DSIGs. I spent my entire day trying to figure out how to make that thing work. I remember sitting as a Brigade S2 in 3rd Brigade 1st Cav looking at my XO, Brigade XO, who's now the commander of AFC, but he was yelling at me, I'm going to fire you if you don't figure out how to run that box. And I remember just sitting at that, looked like a hog looking at a stopwatch. I didn't know what to do. As I did figure it out, I figured out how to get dots on there, but I didn't know how to make the dots right. I didn't know how to correlate them. I didn't know how to normalize them. I'd spent all day trying to change the nomenclature of tank battalion manually on dots with my analysts. And so the bottom line is a very inefficient way to get situational awareness. But the bigger part is I couldn't get my red dots onto the CPOF. So what we'd have to do, take a screenshot, put it on a PowerPoint slide, and kick it over. And that was how we spread situational awareness. We weren't all together sitting around a map board anymore like we did before the war started. That was in 2004. Fast forward to 2020. I'm a Corps G2. I'm the senior intel guy in a Corps footprint. I'm working for General George. I'm getting red dots on my screen, now DSIGs. Do you think I could pass it over to the artillery units seamlessly? No. 2020, 15 years later, I'm a colonel, Corps G2, running across the fist cord with grids on a yellow sticky note so they could shoot the targets. And fast forward, I'm the J2 of the National Mission Force, Joint Special Operations Command. In our JOC during live operations, combat operations, we had 5 screens, 5 different views of the enemy and friendly, because each different application did a different thing. We didn't have a fused picture. That was a year and a half ago. As Casey mentioned, we went to visit 3rd Corps and 4th ID and 1st Cav. They talked about, their G4 folks talked about how they ran crunched numbers on spreadsheets because they didn't have an application that could do it. And we had some of the best engineers in the world with us, and they're absolutely mind blown that in 2024, 2025, we have soldiers that can't get data into mission command systems, and they have to go outside the secure area, and use their iPhone to Google formulas that they could put in Excel so they could figure out where their ammunition was. And they were just like, how are we in the 21st century and we can't figure this out? And the reason is, and my boss always tells us, General Rainey always tells us, because Army guys can't do code. Army guys know what they want, but they give very, I would say, pedantic requirements to industry to help us figure these things out. So all that is background. About 2 years ago, Mike and I came onto this, and General Rainey pulled us in. I'm, like I said, an intel guy that's mad at the world when it comes to mission command systems, but I was pretty good at doing intel stuff. But he pulled us in and said, I want you guys to fix the network. And we said, sure, that's a pretty tall order. What do you mean?
Broad statement.
Broad statement. He said, I hate AFATADs. So I'm like, okay, so we went quickly from network to I don't like the artillery system, but that helped give us a little bit of clarity on what it is we were supposed to do. Understand the problems in the mission command system, which I kind of talked about, and then as we build a new mission command system, figure out the network that we need to build to drive it, because what we have right now doesn't work. As I mentioned before, I was a Corps G2. We had various and sundry systems inside the Corps command post and 20 megabytes a second of upload speed for dozens and dozens of bandwidth hogs that are inside the command post. So we came up with a plan, and I'll talk about it here in a second. But at the macro level, that means we want to get away from everybody having a box. We are a hardware-centric mission command ecosystem. We buy the best kit, buy the best hardware, and then throw crappy software on it. I tell a lot of people it's like having a super nice deer rifle without a scope. Doesn't do you any good to have a super nice deer rifle if you can't see what you're shooting at. So that's the first thing. The second thing, I talked about data models, and everybody has their own data model and their own data ingest point. Getting rid of that. We want to have cloud native, software first, hardware agnostic ecosystem that has it. Everybody sees the same data at the same time. That's our first principle. And the reason for that is there's a couple reasons for that. Is we kind of gave that big macro level view of what we want to do to General George when he was the vice at the time. He was kind of thinking through his priorities before he became the chief. He's like, remember when we were at First Corps together? And he did. We walked around the command post one day. The way he liked to say it, I'm talking to the ambassador, but it was really just walking around and checking troops and training. We had 15 tents, about 400 people, about a dozen generators, about, 20, 25, 30 servers inside there. And it's not a survivable command post. We evolved that way because we lived in safety during the global war on terror for the most part with the command post, but we can't live that way with large-scale combat operations. So he said, I want you to make the command post disaggregatable and survivable. I want most of the people that are in there to operate from sanctuary. So that's why we have to be cloud native, so we can see seamlessly the data, whether it's in sanctuary at the command post, and we can break down talks and move them quickly. So you see the picture up there, if you go to the next slide. That kind of gives you...
Or you want to go to the slide?
This is where I want to be. So I kind of talked to you about what it is and what it's not, but the picture on the right kind of denotes where we want to be. Like I said, we had server stacks, we had laptops, we had radios, but if we go server-centric and we go digital comms, we want to get to the place where we have tablets in the command posts and the vehicles, ATAC devices by that phone, watches as individual pieces of kit. And the reason for the tablets is we've been trapped in the command post with other hardware. And General George's vision is to have that tablet inside of a combat vehicle that can get dismounted and moved into a command post and hooked up to a projector. And that commander never loses sight of what's happening in the battlefield. That phone, we're moving out with ATAC devices, a tactical awareness kit, and the ATAC is the Android code baseline. Each soldier, each squad leader and above will have that on their body armor. And going back to that integrated data layer, the company commander, battalion commander can see the same view of the enemy as that soldier can on that TAC device, albeit a little bit winnowed down based on what we have for backhaul requirements. But those TAC devices also allow fire missions at a touch, 9-line medevacs at a touch, logistics reports and requests at a touch, which is a sea change from back in the day when all you had was a radio and you're scared and you're trying to shout things in the fire missions or whatever and messing them up, 9-line medevac requests, messing them up. So we're trying to use a simplified user interface backed up by AI, ML recognition tools. When I say that, people liberally use that term, but that specific use case, the AI is you can talk into the phone, talk into that ATAC device, and it can translate a fire mission for you. So that's kind of what we're looking at. But bottom line, software-centric, hardware-agnostic, unified data. Those are the three kind of points. You go to the next slide, please. So Casey talked about earlier, we'd gone to get some user feedback on what this thing should be, and we've been with units in various demonstrations. The things that you hear the most from soldiers is the ability to pass data and pass their work seamlessly across that data flow instead of having to screenshot it and put it onto PowerPoint slides. So a litmus test for as we're using our current ecosystem, we have several vendors that are building mission command applications as long as an operating system for us. And for this to work and for you to work in our ecosystem, we want a forward-facing application to be able to use graphic control measures, draw graphic control measures on that mission command application. It hits the microservice, and everything else inside of the ecosystem can see graphic control measures. Chat, and this one actually came specifically from General George. As he's gone around and seen the C2 fix units, one thing people can't do is do cross-application or cross-platform chat, and that's a huge deal in an operational situation. It gives you a lot more clarity in what's happening on the ground than somebody shouting in the radio. But we have both of those things. But that's something for him that's a litmus test. PLI. That's kind of my leading statement, the position location information. We're just barely getting there with our prototyping of Next-Gen C2, where everybody can see the same PLI. I can't overstate, like that's step one on having a good mission command system, so people can see and understand what's happening on the battlefield. And Mike, I'll kick it to you for that last tab.
Everything that Matt said to this point, it's all been about data, right? And we have an insatiable need, and our commanders have an insatiable desire for data at the edge, right? This is the future. Data is going to win warfare in the 21st century. So as we think about that data, how do we think about this? This is, I mentioned broad statement that General Rainey, when he said fix the network, it is broad. This is a complicated, broad, challenging dilemma. It's a challenging problem. And the best way that we can do this is to break it down, right? And the next chart you're going to see is going to show the way that we've broken this down for simplicity and the way that we're thinking through the problem so you have a better understanding. But I've been in your shoes, right? For the S6, G6 community in this room, I have been in your shoes at every echelon, right? And we know how difficult it is. And I understand how difficult and all your pain points, because we're still living the same pain points today of not having the network, not having the availability of the bandwidth that we need, not having the ease of access of establishing connectivity, working with RHNs, everything else that you guys have to deal with. We've been dealing with that for as long as I've been in the career, my 26 years, right? It has not been solved up to this point. It is a tough problem. There's reasons for that. It's not because we don't want to solve it. It's because it's a tough problem, but we have to think about this differently. We have to have some different opinions and thoughts in the way that we approach this problem. And so we'll move on, and Colonel Skaggs will talk about the chart.
So this next chart, that slide on the right, or that figure on the right, you heard me talk about how we got told to build a new network, and we briefed it to General Rainey and General George, and that chart is where we started. That everything Next Gen C2 is based on that chart. 2 years old, and we show it every day. This is fundamentally how we call this our software stack, and this is how we were designing what we want to do. At the top, those orange boxes, that's our application layer. And that middle box there, that's what we call our middleware layer. It's where the operating system sits. And then below is our infrastructure as a service, so that's storage and compute and transport. So at the top, what's different, I think what's disruptive about what we're doing here is that, you heard me mention all the systems in the past. What we did was a software vertical. Every different application had its own data ingest, its own middleware, its own application. And that application is what we trained soldiers to use, whether good, bad, or indifferent. I remember shouting at the sky when I was the 25th G2 about how D6 didn't work. And the response I got back from my tribal and my elders was that you're not trying hard enough and you're not training your soldiers. And I tell you, that's aggravated me for 20 years. And meanwhile, anybody can take an iPhone out of the box and know how to use it immediately. Nobody goes to iPhone school. What, you know what I mean? Why can't we make our mission command systems like that? So you see a bunch of different boxes that, attached goes through the warfighting functions, intel, operations, fires, etc. Where we want to be is just, we're like all about this iPhone analogy, right? We want to have a multitude of apps in a competitive ecosystem that vendors throw their app up, whether it's a mission command application or an intelligence application or a fires clearance application or airspace tracking. We want people to come in and compete for the usage of those applications and give soldiers and commanders a lot of options on how they want to see data and manipulate the data and track the battle. So at the end of the day, we want apps to be disposable. If they're no longer fulfilling the requirements of the users and somebody's got something better, well, we want to get rid of it, as opposed to saying you're not trying hard enough. You don't love America enough to learn your system. Not that I'm frustrated by that. The second, that middle layer is really, what soldiers do and how this thing's used is obviously the most important thing, but the real most important thing is that midware. And then we have core services, common microservices that that make the data extensible so each of those applications that I just talked about can equally see the data and equally visualize the data. To the iPhone analogy, this is our iOS. This is where we have our AI enclave. We have what we like to call a model garden, where companies can throw smaller, tractable, easily trainable models inside of a specifically administered AI enclave. This is where we have our identity management. This is where we have data normalization and correlation. All those things that I used to have to do by hand, and all of us used to have to do by hand when we were a kid. We want to automate all those things. So all of that said, we built this chart. We showed it to General George. He said, "That's great. I want you to show me it for real in 90 days." So we had to go from PowerPoint chart to an actual system in 90 days. So we contracted some teammates, a consortium of industry, to go out and demonstrate this at Project Convergence Capstone 4. So we had the operating system. We had several different applications. We had the software centricity and the hardware agnostic. We had the tablets on tanks, et cetera, et cetera. And really, we was all on IL2, all on dirty internet, so we were cheating and faking the funk a little bit, simulated the PLI, but the ecosystem worked, the microservices worked, the apps worked, we were passing graphics, and it was maximum victory. So General George came through, we demoed it. He's like, "This is great. I want it in the hands of soldiers next month." And we're like, So what we had to do, because that's where the third core thing started, and we got user feedback and we did some demos, but it wasn't quite ready. We're on glide path to this next Project Convergence Capstone 5 to have this mounted on tactical vehicles. We got everything kicked up to IL6, which everybody knows if it's not on SIPR, it's not really a mission command system. So we're on glide path. But all that said, this is still demo land, and it's all going to get blown up after PCC 5. So the real thing is how do we flip this to acquisition so it becomes a real program? So we did the software user agreement. We're in the first stages of becoming a program of record. But the most important thing where I'm going with all this is all the words on the left. All the demonstration that we did and all the experimentation we did to figure out how to make that PowerPoint slide into an actual system came out into what's called a characteristics of need, which is a broad macro level requirements document. And you can see all those things on the left. Trainability, like I talked about, nobody goes to iPhone school. Common platform services, I kind of touched on those things, microservices, graphics, voice over IP, the cross-platform chat that I talked about in the first slide. Cloud native, we want to get away from server stacks and the command posts. Open and standardized architecture, we want people to build an application with the data extensibility and just pop into the ecosystem. Easily learnable UI, UX, and then the threat-informed network. And I'll pass it over to you, Mike.
Yeah, so Colonel Skaggs mentioned iOS as the core and iPhone not needing that level of simplicity, that level of performance. That level of reliability is what our commanders expect, and it's what our Army needs to fight tomorrow. The problem is that when we're in conflict, we're not going to have ubiquitous access to 5G towers and everything else to be able to sync that data real time. It's not going to exist. We, in most cases, in most environments, and let's go in the future, against a peer enemy, will not have that level of access. And that's the way we need to think. We need to think worst case, pure threat, pure enemy. Everything that we can do to him, he can do to us, right? So he can take it away at a moment's notice, and we need to be able to adapt. So if this data is so important, and what Colonel Skaggs has been leading on the data front of this is so important, that data integration layer, that UI is so important, and it is, no doubt about it. And we have to figure out how do we ensure and assure that that data gets to our commanders complete and protected, right? And so we just, so Colonel Skaggs mentioned our initial demo at Capstone 4 and the lead up to where we're going to be in Capstone 5 in March. If you could go to the next slide, please. In between, we just in September conducted, DEVCOM C5ISR conducts an annual exercise called NetModX every year. NetModX, it's a network modernization experiment is what it stands for. This year, we integrated Next-Gen C2. So the problem statement of how do we take what was demoed at PCC4 and assure its functionality in a contested environment was what we really focused on. And we did that. We physically contested the spectrum. And we wanted to see how would the software react when not all of that in a DDoS, when not all of that bandwidth is available, if our network is degraded, if it's disrupted, and what happens if we're disconnected, right? Does that mean we just don't have access to anything? Can we still process things locally at the edge? What about the sensors and the machines in the future that are going to be assigned to my formation, and I need to get that sensor data off? Do I need to network for that? Do I need to go back to the cloud for that, right? The answer should be no, because that won't be there. So this is why we need to kind of start to rethink. So the outcome and the insights of NetModX, first off, we have to reimagine, I think, what a software-defined network is. What does that look like in the future? I think we know what it looks like today. Colonel Skaggs articulated the need to bring in AI and ML. That's not only for decision-making, that's going to have to be also decision-making for the network. So that was one, right? So let's get smarter about what our networks and ensure that we truly have a threat-informed, intelligent network, a network that understands what the adversary is doing in the EMS, how it's contesting us, and how he can target us through the EMS. Second one was, how are we going to ingest data at the edge? How will we host that data and process that data at the edge if we are in a DDoS environment? That's where we started rethinking, what does a low swap, high capacity edge compute requirement look like? Third thing, how do we prioritize the data sets? So what Colonel Skaggs is talking about, what he's accomplishing, if we can't get all of that data, if it's not entirely complete because we're in a degraded environment, how do we ensure that we're getting the data sets that are most important to him and most important to our commanders to that tactical edge? So how do we do that? And then fourth, I would say, is software. We have to think a little bit differently. This is not just a network problem, right? Usually it's, hey guys, G6, figure it out, man. You got to figure out how to get that data to the point of need. Okay, help me out a little bit. Meet me in the middle. Meet me in the middle from a software perspective is we need leaner software sets. What we also found in NetModX is the majority of our software is just too heavy and it's not optimized for a tactical environment. We couldn't get it to the edge without a lot of bandwidth, without super low latency transport. So that's a different way that we have to think about the problem. We're going to have a number of mission sets in the future that we'll look at, right? The emergence of AR and MR, those are things that we've already brought, that Colonel Skaggs has led, that we've already brought those type of capabilities to the edge, requires a lot of low latency data, right? Robotics, HMI, when we think about human machine integrated formations in the future, that is going to be a real problem for the network, okay? How do we get all of that sensor data off those platforms and get it to the point of need? And so when we think about this, we think, all right, we are going to need some access to the cloud. We're not saying it's not going to be or totally inaccessible. So we think through the problem statement, and I want you guys to think of it this way. Think of the data flows that need to exist cloud to edge. Think of the data flows that need to exist edge to cloud. And think of the data flows that need to exist horizontally edge to edge. So if it's an adjacent unit, you need to share something, but there's no way you're getting that data up to the cloud, but you can minimize your signature by transmitting that data horizontally, and that will work for that operation or that objective. That's the way we need to think about it. Smart, intelligent transport of our data. And then, as I said, or the last thing I'll end with here, I said those three things to think through the problem. Also think through, where is that cloud environment hosted? Is it even realistic to think we would be able to reach back to it? And how do we start thinking through what a fog layer would look like, that middle layer of compute? So maybe I can't get all the way back to the United States to a data center hosted by Google or AWS or whoever, but I can get back to a data center that's regionally supporting a COCOM. Maybe I can, right? That's the forward cloud environment that I can access. And so as long as all of those services and all of those applications and all of that data is replicated there, then this shouldn't be a problem. I've just minimized my risk. I've minimized my signature. I've minimized the transport requirements that we have. I'll let you close.
So what we're trying to do is, it's different. Why is it different? We're not anchoring to vendors. That software stack we showed on that last slide, we want to segment that up and each one of those things be led by a different integrator. And the reason is that it's switching costs, right? There's companies that we've contracted with over the years to provide us that whole stack, and they tell us we own our own data, but when we're not happy with that system, we're still stuck, vendor lock. And the way we're segmenting the stack and segmenting the services and the applications is the opposite of that. It's the conglomeration of a lot of people trying to get to an end, and it's all based on user demand and easy use. And everybody can, and democratizing data, I got hung up on that word. Everybody has equal access to the data. I'm not going to be an Intel guy running across the FISCORD and wondering why they've got a different enemy read than I have. Everybody sees the same thing. So that gets back to where we started from with the analog board and the push pins. When things felt right and when we trusted what we had, and we didn't have to worry about data compatibility or pushing data across a DDS, or we didn't have to worry about whether or not our millimeter wave shot was working or our HICLO shot was working. Things have gotten a lot more complicated, but now we know where we need to go. But again, the big difference is it's not Army guys. We say, now we're saying generally what we want it to do, but we're not dictating how to do it. And that's how we've messed up over the years with how we write requirements. And now we're looking to industry and other experts to help us figure out how to get there from here. So we really appreciate the attendance on this and lending your experience and wisdom to what we're trying to solve. And we've got about 15 minutes left on the stage for question and answers with the group or online.
Hey, good morning. Robert Douthit. I had the honor and pleasure of being an Army requirements officer from 2004 to 2006. We were transitioning from semaphore flags into carrier pigeon. Literally watched as FCS was a program being run by a contractor. Love the vision, I dare say probably everybody does. When you think about fielding something as vast and as this is, iteratively, how do you preclude those same sort of errors that we saw in FCS, which was going to be an all-encompassing sort of physical requirement system as opposed to a communication requirement system? Where are the checks and balances as you learn from industry, which everybody wants the government to do, versus laying out the sort of the requirements? I know General Rainey talks about one sentence. Let me give it to him in one sentence and go from there.
So that's a great question. And we get a lot of FaceTime with Army senior leaders on this, whether we like it or not, right? And as we've pitched the vision and the lessons learned and the things we want to do to the under especially, he literally says, how do we keep this from becoming FCS? Because we do what we call application convergence and workflow convergence into one system. It's somewhat inevitable that those conclusions will get drawn, I think. And so there's a little bit of creativity on how we have to do this with how, one, we write the requirements, and two, how we fund it. Because first and foremost, if you do everything onto a single line item in the budget, then as the under says, this thing's going to collapse on itself. So we have to spread it around. We haven't gotten that far down the road, but the back of the napkin math is different PEOs are going to have to own separate line items that have parts that fit inside of the overall system. So we talked yesterday, we were talking to G8, there's still a role for IEWS, there's still a role for C3N, there's still a role for different PMs underneath that. But more importantly, as we build out the governance, everybody's going to kind of have a vote for their part of the ecosystem. So it's not one Uber overlord. We do have what we call benevolent dictators. Somebody's got to call the shots, but otherwise, but that like a half a step down, all the other CDIDs inside of the Army are going to be responsible for requirements for their warfighting function and how they fit inside of the ecosystem, the different centers of excellence, because we're very tech focused on how to build the stack and how to build the transport. But where we need the next step of this is the .mil PFP implications, whether it's the training or the doctrine, how, like, potentially if we do this right, what does the op order look like? what does an INT-SUM look like? Do we even need to do that anymore? So it's a very complex problem, but you can see how we're trying to bin it out and put it in different baskets so we don't have this one, the tallest nail is always the first one to get hammered kind of a situation.
And the funding.
The funding.
Sure.
On the funding effort, how that comes together.
Yeah, so that's going on as we speak, candidly, and we're trying to figure out how to not take all the money from current systems and put it into one pot, but have some of those funding from previous programs that got sunsetted. How do they fund FIRES apps, mission command apps? But yeah, you're spot on. It's almost like you're in the room with us.
Hi there, Eric Hanf with T-Square Labs. In all of these different pieces or segments of what you're trying to solve, if you look at the solutions today, there's a lot of custom purpose-built hardware that it's high cost. There's a contested logistics problem. So I think there's a general consensus that commoditized hardware paired with special software is easier, cheaper, faster, right? But when you get a solution from a vendor, if they're going to build you a custom piece of hardware, maybe they can meet like 100% of the things that you ask for. Or the next vendor offers you software plus commercial or commoditized hardware and it's 90%. Like how, across each of those different parts of the network, how do you create a common theme of like, are we orienting towards software on COTS or custom hardware? And if we're submitting, how do we as vendors know where we're going to find custom hardware versus commodity hardware?
Yeah, I don't know if there's anything as far as commoditize or how we're going to do this, in the big picture. Eric, I don't know. I don't have a good answer for you. I just don't think that we're going to, have one set solution, and we're not going to know what the requirement is all the time. It's going to be continuously evolving. So if we can evolve, if our hardware is configurable and it's modular, that's where I'm looking right now, right? That's because we don't know what the future is going to hold. We have changed so much just since PCC4. Our mindset has changed so much since PCC4. So what I value modularity. I value the ability to be configurable with our hardware and not to look at one standard set of anything, right? So if we're going to buy a COT solution, the expectation, or if we lease, and really that's the area that we want to get to, if we're leasing a COTS hardware solution, the expectation is, and what will be written in the contract is that it is configurable to meet an evolving mission set or evolving set of requirements. Hopefully that's helpful.
To pile on, we get a lot of guidance, as I said, and two things. The Army senior leaders, three things. The Army senior leaders say perfect is the enemy of good enough all the time. And I was part of writing the requirements for the Army Intel Data Program, AIDP, and we had the best requirements money could buy in 2014, and was the 100% solution. And it's just now getting rolled out in 2024. Could you imagine buying an iPhone in 2014 and still wanting it in 2024? Back to that iPhone analogy. So what we're doing now is the software acquisition pathway. This is the first program that's all in on that. SWP is the acronym. I don't know where the A went, but what that means, though, is that characteristics of need statement and then a CNS is, as we get it out, will constantly change. So what we're aiming for is a 60 or 70% solution just to get this thing going. And then we have, as we get the user engagement and the feedback and these things out in the field, then we modify the requirement, change the software. So that's also going to be true of the hardware side. So I don't think we're ever going to want to be in a place where we want 100% solution because it's only 100% for like a week and then it becomes 90%, 60%. So those are the kinds of things. And the third thing that we got specifically from General Rainey on the hardware side is as a service. It's like a mantra for him. He wants as a service. So as we get hardware, we want a contract for a capability, not a piece of kit. So once that piece of kit's no longer any good or it stops working, we can just get that. We can get that switched out. So we've got it's a little, kind of a spectrum of feedback on that as a service bit, but that's still where he wants to be with this. So I think to your point, we don't want to ever be at the 100% solution because it's fleeting.
This is Charles Cullen with Cybernet Systems over here. Hi. I applaud your focus on data transportability and analysis and all that. But in all those requirements, you never really mention power. So I'm going to do another hardware discussion. And I can't imagine, especially if you push AI onto it, all that stuff, that these tablets are going to last more than a few hours, let alone days. How does that work? How do you handle all that?
We are certainly thinking through, I mentioned briefly, low swap, high capacity edge compute. The power is going to be a big deal. We're going to learn that firsthand at PCC5 when we install this, when we try to put data at the edge with vehicle platforms that are not ready to handle it, be quite frank. So we're going to learn, okay, what's the power shortages? What's the decrement? What do we have to do to ensure that we increase that, to put an edge compute device in that, to do something? Because we're going to have to figure out how to process, and if we're going to move forward with AI. We're going to do that, right? So what we really need is the compute and the low swap technology to be able to support that at the edge. When I think through problems, I'm thinking tactical edge backup. We have to solve the tactical edge first. And I'll frame that for you. We're really thinking about the platoon to company as being that tactical edge. So if you start thinking tactical edge backup, that will help in framing what those requirements are going to be. But I certainly think we are going to have to process, going back to the disconnected area that we discussed earlier, we are going to have to process that level of data at the edge, and we will have to integrate AI capabilities at the edge. In order to do that intel analysis at the edge, real time, at the speed we expect LISCO to be, we're going to have to run robots at the edge. We're going to do AR/MR at the edge. Like, that's the future, right? It's a very tough problem. And right now, it's certainly not in the solved category, because the technology right now doesn't exist to support that at the edge. Not with the power requirements. We talk about contested logistics, right? We're not going to have big generators getting fueled up every 8 hours. That's not going to exist. So we're going to be running off of vehicles. So we have a lot of limitations and some constraints right now, but the demand signal is there, and we're ensuring that demand signal is there so we can ensure the requirements are written appropriately. This is why it spans broader than just the network. It spans the way that our vehicle platforms are being built. It's going to span the way that our aircraft platforms are being built and designed. We're going to have to figure that out. It's a great question. Help us solve it, please.
I think to that end, I mean, not to keep piling on, but I'm compelled. The CON is designed to be collaborative with industry. So as we say, we want these 10 things, we're looking for the yeah buts. You know, yeah, but it's going to cost you. It's going to cost you on size or power, and that way it helps us refine requirements. So we push out the next iteration of the SWP or the CON. You know, we have a better requirement for industry instead of, yeah, verily, this is what we're going with. Oops, forgot power. You know, that's not where we want to be.
Hello, my name's Shank Camdina with HashiCorp. Thank you for the opportunity. A couple questions with regards how your team is working with the actual PMs and PEOs. I know you mentioned software acquisition pathways. Where in the process does the PM come into play, especially Michigan Command, you know, with their AXS program and other things? And then two, can you describe or talk about how you want to deliver capability in terms of risk? Is one of the bigger challenges that we've seen over the years with any of these programs that come out of Michigan is, you know, there was the sit-aware buy, there was CPOF, there was, you know, there's what D6 is doing, you know, and then the
All my
Palantir.
favorite things.
Yeah, but specifically what we find is that there's a lot of requirements bundled into one acquisition, and then it takes a lot to break that apart, or it just takes a lot. And there's a lot of how would you go about sort of breaking it down so that industry will be willing to shoot at things more often and faster, you know, from a software development perspective?
So, great question. So 2 answers. First, this started with, it was a unilateral AFC project, and we kind of alluded to that. We were running the whole thing. But as things matured and this got legs, almost probably 6 months in, Mr. Bush wanted to be a part of this, so we started that probably 6 months in, going hand in hand with C3N and PM Mission Command. So as of right now, we talk to them almost every day, and everything we do is hand in hand with PM Mission Command and PO C3N. Because ultimately, as I mentioned, we're building the requirement, we're experimenting and figuring out how this thing should go. Come PCC 5, we're kicking so we're the supported command right now. As soon as PCC 5 comes, we're going to kick it over the fence, and we're going to be the supporting command. So we'll still own the requirement, but all the acquisition is absolutely going to go as the PM Mission Command. The second part of your question, I think in summation up front is to keep the main thing, right? We don't want to do too many things at once. Getting an integrated data ingest layer, and so we can correlate and normalize all that data before it hits the middleware, have some pretty simple functionality in that middleware, like I said, some voice and chat microservices and a graphics microservice, identity management, some tractable MI or AI models, and then a couple of applications. I think up front we're just shooting for foundational mission command applications that do the big six, the red and blue PLI, graphic control measures, collaboration, workflows, a map service, terrain service, or offensive, defensive fires. I mean, those are written into the CON. And that's candidly why we went with a very simple kind of a 10-point characteristics of need so industry can say, I can fit in one of those places. And then we just do fundamentals. And then we start adding on complexity as we figure out the fundamentals, the data extensibility, the microservices, and then the application ecosystem. But again, easy stuff. We don't want to do everything at once up front like D6 tried to do or CPOP tried to do, because then you get a system that doesn't work.
Got to keep C2 the central focal point, right? Every other warfighting function supports C2. And as long as we have that framework, when we start to think about how we're going to develop our requirements, that's exactly how we're going to do the harder part. And what's not solved yet, but we know is going to be the hard part, is centralized governance and how we're going to govern it long term. So we can get to a point where we need to be to move out into the program, but how do we sustain that over time? Because every CDID, every COE is going to have its operational requirement. So how do you ensure that C2 remains a central focal point? And I think the way that the Army is looking at this is looking a little differently. I don't have the answer for you, but I can say we are looking for how we're going to reduce that risk across the board for industry. Jing.
Hey, Colonel Xiao, nice to see you. And thank you for sharing all those software-defined data-centric vision. And we totally agree. And actually, we are doing software-defined, explore those transport efficiency. We already demonstrated just using software, we can triple or maybe sometimes 10x improve the data throughput. My question is, as a Silicon Valley startup, we do not deliver the full system. And usually, in the past, the Army is looking for a full solution, full system. How can we change the mindset and try to foster the industrial collaboration so we can, for example, we do not do full system. We only develop software. But how to collaborate, foster those collaboration from the industry perspective? Thank you.
So first off, the basis of, and Jing, thanks, advanced protocols, advanced waveforms, we didn't talk about it in here, but it's something that we have to think about in the future. But in your case, the advanced protocols that you're working on, this is all about the larger requirement of ensuring that we can reduce the overhead on our network without reducing the data that's going to the edge, right? That needed mission data to the edge, right? We need to get it there, but we have to reduce the network overhead. Advanced protocols, advanced waveforms is one way that we're going to get after that. How we solve there's no one company that is going to solve this problem alone. That's why we have the layer stack. That's why Colonel Skaggs has described how every PEO is going to have a different layer, or a different PM is going to have a different layer of that thing. We're going to break this thing apart. Having a team to look at these things, different industry partners that can come in with different solutions to get after the core requirements that are going to be outlined, that's the key. So I would say, from an industry standpoint, you're incentivized to work together. Because what the Army doesn't want to do is we want to get away from the large traditional LSI. It hasn't worked out well for us in the past. It probably won't work out well for us in the future. So we're moving away from that model as an Army. So we're reimagining what the LSI is going to look like. When we bring in all these folks, like Colonel Skaggs said, that's the way we're going to do it. You're incentivized, or industry should be incentivized to work together, because it's not expected that you're going to solve the problem on your own. I think, do we have time for one more, or are we done? Okay. Looking forward to
And
yeah.
scene.
Yeah.
Okay, I guess we have one coming live stream from YouTube. What is going to be the primary mechanism or platform used for soliciting for and selecting and fielding the solutions for requirements?
Can I read that?
What is going to be the primary mechanism or platform used for soliciting for and selecting / fielding solutions for requirements?
I'm gonna guess that this is more of like a CNS question on the requirements document side of this. So right now, concurrently, as we're moving towards PCC 5, concurrently, we already talked about the PEO. POC3N is moving forward with what the prototype contract is going to be, based on the requirements that are being written today and based on what has already been outlined in the con. The intent, and where C2 CFT, the command and control CFT, is leading the requirements development effort. And right now, that platform, that requirement type is going to be a capability needs statement. Hopefully that answers the question, Matt.
One little bit, we're out of the solicitation game, I'll tell you that straight up. But we're on glide path to finish the Cat 5, and then POC3N has an OTA out and a solicitation out for those that want to compete for the next phase of this. So all of that, all those contract actions and the OTA and the solicitation will happen through POC3N. And that's open right now, I think. I think it's on the website.
Colonel Skaggs,
Thanks.
Colonel Kalushin, thank you for the keynote. We're going to our break now. So we're going to take a 5-minute break. 15-minute break at 10:15. Please back in here, but if you can give our keynote an applause.
get you on.
All right, everyone, we're about a minute away. So if we can start finding our seats and getting comfortable. All right, if everyone could start making their way back to the seats. If you really want one of the comfortable seats, they're empty, so you can snag them. All right, we got some empty seats up here up front. All right. That was pretty good. The keynote was a great discussion. My 5-year-old knows how to use an iPhone better than me. So, next we're going to have our panel. It's going to be moderated by Mark Parmalu, senior reporter at Defense Scoop. It'll be the soldier experience. Please welcome him to the stage and the rest of the panelists.
All righty. Good morning. Can everyone hear me? All right. I'm Mark. I'm a senior reporter with Defense Scoop, as you just heard. We have a really exciting panel. You're going to hear from the soldier perspective here. Really great lineup of speakers. All Division 6 is here. Right here, we have Audrey Tumalu from 1st Cav. And then right next to her, Mr. Clifton Huber with 4th ID. And then last but certainly not least is Mr. Timothy Jones, the G6 with the 82nd Airborne Division. It's obviously no secret that the Army is going to the division as the unit of action, now vice the brigade, which obviously means bringing a lot of that network complexity up to the division level here. And so what I'd like to have our panelists do is kind of just run through some of their main challenges that they're seeing at their level, give a little bit of information about how their formation fights as the Army is building out its network. It's not going to be a one-size-fits-all. Each formation fights a little bit differently and thus requires different types of capabilities and tools. And so why don't you kick us off right here?
Absolutely. Thank you, Mark. So because I have first speaking role, I'm going to go ahead and brag that 1st Cavalry Division is the Army's premier division and the 11th Army Division.
Save the best for last.
We'll see. Okay. Well, but thank you for the opportunity to be up here so we can articulate some of the challenges we're seeing, at the front lines. So unique to my formation and how we fight is that we fight over longer distances and we do it at a faster speed. And with this, we do this with tanks and indirect fire, so we bring overwhelming firepower, speed, and precision. And the way we do this is through the kill chain process. We find, fix, target, engage, and assess. And so my role as the G6 is the informational aspect of this process. It means access to timely, relevant information at echelon, and the interconnections between the sensor, the warfighter, and the mission command systems enabling the firepower assets is imperative to maintaining our speed and our precision. So my challenges, I think Colonel Kalushin and Colonel Skaggs did a fantastic job articulating some of those challenges down at the forefront. So out of script, I will invite you, if you have any follow-on questions, to ask them, but then I probably will be looking their way to answer some of those. So if you didn't get to ask your question before, this will be your other opportunity. So my struggle is that my systems right now, my formation's current C2 capabilities, they have high latency and low bandwidth. And they're coupled with size and weight, which adds increased logistical challenges and constraints to our maneuver commanders. And furthermore, when we go through modernization efforts, for our hardware, that adds to space and power constraints, in our platforms. And this decreases, obviously, their ability to maneuver and maintain continuous C2 on the move. So what do I need? I know we're actively talking about transport options and transport capabilities because that's essential to the cloud services that we talked about and spoke about earlier. But with the proliferation and globalization of low Earth orbit satellites, 5G LTE capabilities, I think we're doing a pretty good job looking at those options and bringing those into the formations. But what I want to add to that is the capability where we can tap into some of our local host nation fiber connectivity lines and relearning that trade and bringing that back to the formation just based off of how we're changing how we fight in our command post nodes and hardened buildings. In addition to these transport options, I challenge this audience to help me figure out how we can employ AI and ML or capabilities that can enable a self-healing network and understand the environment that I'm in, especially in contested environments, our electromagnetic signatures, choosing the best transport for assured connection, but also somewhat like a smart network that operates like an eco-friendly vehicle at a stoplight. When it knows and learns that my system or I am idle, it tones my signature down. And I'm not emitting at all times, and this can help me blend or obscure my electromagnetic signature when I'm operating in contested environments. The second thing I'll bring to light is something that we've already talked about, consolidating, centralizing compute and storage capabilities. And this will rid me of those large baseband nodes that I have to tug along across that dispersed battlefield. But also, one of the assets that I'd like to see if we can get help on is our encryption devices. There's so many of them, and we need one for every network enclave that we're employing at the tactical edge. And if I can find a solution where I have a single encryption device that can do all the enclaves that I need at the tactical edge, and that helps to lighten my load. And then lastly, platform agnostic systems capable of meeting our demands of increased op-tempo and higher data requirements. Can I use this in every single platform I have in my formation? And this is not just the warfighter. These are my enablers as well, who tend to be the last in the chute whenever we have capability fieldings. Can I use this in a hardened infrastructure? Is it modular where I can take it off of those platforms and put it in a hardened building and use it when I'm setting up an ad hoc command post? Is it compatible with legacy systems? And is it interoperable with my joint and multinational partners that I will be operating with? And so those are some of the challenges I wanted to bring to the table for you. Hopefully, that's something that we can look forward to in the coming years. But that's the long pole in the tent as far as 1st Cavalry Division soldiers at the tactical edge.
So, Colonel Hubbard here. I joined the Army in 2002 in the National Guard. I commissioned in 2005. Armor, branch detail, signal. So ABCT was my start, the Heavy Brigade Combat Team. I was company commander and S6 with them. I then moved to 25th ID, so a light division. I am now 4th Infantry Division, which is a striker division. So I've gone from heavy to light to the medium, now in the middle. What is common is our tactical network and our information requirements. How we get that information up to each level is slightly different, and how much transport capability we have for the heavy equipment in the light units hard to move big, heavy server stacks. While in a heavy unit, it's pretty easy. In the medium unit, the Strikers, we have some space. We don't have quite as much space. We don't have as much transportability, but we have some. So it's capable. It is pretty simple to do, but we need faster techniques to be on the move. We are an at-the-halt organization with our transport. That is how we were designed with WinT back in the day. It was all at the halt. There was very limited on the move. Now we're trying to do on the move and be very diverse in our paths and have everybody moving with different network connections all the time. So if you pull up my slide, a little bit about Fourth ID is the marquee multi-domain operations division for the Army. What we are trying to do is we are integrating all of our partners, and you can see a list of partners up there. One of the unique spots of being at Fort Carson for us is we have 1st Space Brigade. There's only one Space Brigade in the Army. There's only one NORTHCOM in DOD, and they are right there. We have Peterson Air Force Base, we have Cheyenne Space Force Base, and Fort Carson, and then Pinyon Canyon, which is a giant training area about 150 miles south of us. What that does, it allows us to disperse our forces, do some electronic warfare capabilities down there at Pinyon Canyon, because it's a very segregated area from the rest. There's not a big formation out there. There's no big city right nearby. So it gives us this training space that allows us to integrate multi-domain operations with SFAB, with Space Force, with Space Brigade. So it's a very unique situation that we have, and we're constantly trying to integrate. What that does is a challenge. If you bring up my next slide, we did 2 exercises. One right before I got there, which was Ivy Mass. So you had all the old Army staff there that had been for the division training for the past year. And we did this giant integration exercise and brought in lethal and non-lethal effects. What they learned out of it is bringing everybody together. They were able to collaborate between units very well. The collaboration and camaraderie, bringing everybody together, was great. The integration was terrible. Bringing all of our command systems together, integrating across joint environments to integrate communication just was hard. It didn't work quite as well. We had to do swivel chair, turn to each other, this system to that system, call for fire, and you had the human in the loop. It was not data-centric. It was not smooth. It was smooth as humans could make it. Bringing us into our next exercise, which was Lethal Ivy. This was our division staff X. So we onboard a lot of people during the summer as everybody's summer movers. We had to train. So what it became, it becomes a week to 2 weeks of training all the new staff. You got to train them on the new system because they came from 1st Cavalry Division, from 82nd, where it's some different method. So everybody has a different method, similar systems, similar computers, but we all use them differently. So you spend 1 to 2 weeks every single time training up the new staff. This is true for every single organization you go to, every single exercise. If I go to war today, I'm going to get all these attachments from across the Army come to me. And they have their way, they've trained on their systems, they know how to use their systems, but then they come to 4th ID, or they go to 1st Cavalry Division, 82nd, or any division out there, and they have to relearn how that division's going to fight, how that higher headquarters is going to fight when you go to that place. So creating a baseline system, that end tablet or computer or phone, I like the example they used earlier, is you have the common phone. That phone doesn't care what network it's on, doesn't care who the service provider is. Your phone, iOS on it, is the iOS, and you're familiar with it. And you can do whatever you need with it. You run your updates, it comes from somewhere. When you don't have a network, there is other ways to connect. If I don't have service in this building right now, I can turn my Wi-Fi on, and I can connect to the local Wi-Fi. If that wasn't working, I might have a computer that it can plug into and download data. So thinking along those lines is what's going to make us successful when it comes to our combat systems. Having that common end user computer, tablet, whatever it is that everybody's familiar with across the entire Army, DOD, that then integrates into apps behind the scenes, and you pull up whatever application your MOS, your specialty is, so you can see what data you need. The other unique thing about us is we are not a C2 fix organization. We're C2 next. So we're not getting any new tech right this minute. The newest tech, though, that we do have is our command post platform. So we are on CPI2 training. We tested the Inc. 0 platform and now the Inc. 1. And so we have a full division headquarters set of it. They're actually out there this week integrating the division TAC, the main, and rear area command post into CPI2, which allows us some on-the-move capability. The problem with it is how do you disperse that now? Because I can disperse up to 3 network locations in reality. 3 is the number of CPNs and TCNs I have. So that's my limiting factor. So I can only put 3 groups out on the battlefield, and they have to remain within a certain distance of each other. How do I put a scalable size network attachment to each of them? If I can do that, then I can spread them out across the battlefield wherever they need to be, and it won't matter where anybody's at because they'll each be connected. But now I got clusters of people that are hovered around still to that one satellite connection to the rest of the world. So open for any other discussion, but I'm going to pass it over to Tim.
Thanks, Cliff. So the 82nd Airborne Division, we have the same technical challenges as 1st Cav or 4th ID or the challenges that both Colonel Kalush and Colonel Skaggs highlighted earlier during the keynote. The thing about the 82nd that makes us extremely unique is we're light, all right? We don't have the capability to bring large packages. We do the same thing that the 101st, 10th Mountain, 25th ID does, but we just do it faster because we have another mission essential task, which is the JFEA, was a Joint Forcible Entry Airborne. My background, I've spent most of my career in airborne light infantry units at the company level. 2 times in the 82nd, this is my 3rd tour. Spent some time in Vicenza in the 173rd, all as a communicator. So it's something I lived with my entire life. So just in a very visceral way, I'll describe kind of the way the division fights for us, and it kind of highlights some of our challenges. And my CG always talks about the right capability to the right leaders at the right time. Because it's not necessarily this full-scale suite of C4I capability at any given time. When you're exiting the aircraft, it's what you have at that particular time. So with the 82nd, we're usually the first one in, right? We're the first one in, we're into the breach first. And if you think of large-scale combat operations, the first thing you have to, if we're dealing with near-peer adversaries, that area denial, area access bubble that we have to eliminate. And once that's done, then we got to chop the enemy down. And once the enemy's chopped down through the joint force, then you throw some paratroopers at them. And once we're in there, we got to tear them apart from the inside. All right, all under the period of darkness, all while trying to communicate in flight. So there's a joint aspect too. Communications en route. And so that intel picture may have changed. The things on the drop zone may have changed. So whatever that key terrain is, we go in, we fight. And then we're doing it in the dark, in the cold, anywhere in the world under the period of darkness. And I say all that because, we're not getting any additional help. So as we talk about adding capability to the edge, it's the same communicators I have. The MTO is not changing, so it has to be intuitive. These are folks that are tired, they're hungry. They've probably been in a harness for about 8 hours before they exited the aircraft, and then they have to put these systems in place. And we're not talking, we don't have, 2 days to set up our systems. You have within the first 15, 20 minutes. And what is that? That could be something as simple as secure voice. And then being able to talk across echelon through secure voice. And then we build up afterwards. So I bring what I can carry. And then the core C2 functions that we look at is secure voice, whatever means that is. Having a data aggregator for that secure voice. So if you're on a FM radio, if you're on a cell phone, if you're on an ITN network, how do we have all that communicate together instead of me carrying 3 or 4 separate radios? Because when I'm jumping in, my rucksack already weighs 65 pounds. I've got the environmental gear I got to bring. I've got to bring water. I've got to bring food. I've got to bring ammo, and then you got to shove all the communications gear on top of that. So those are the challenges that we face. Is what's the right capability during the first 96 hours right? And how are we able to pull all that data in, conduct our C2 functions, which is voice, chat, some sort of COP, PLI capability, and then what form of collaboration, all on a very, very small scale. And then also with the 82nd, unlike first cap and fourth ID, we're very mature with the integrated tactical network capability. And that brings along its own challenges as well. We're probably the most mature division outside the 25th ID and the 101st with the ITN. But that's a different enclave. So when you're dealing with brigade and below, which are pretty much ITN pure, you're operating on the SBE network, secure but unclassified encrypted network, which is great and it's wonderful. At the division, we do ITN, but at the same time, a lot of the data, the ingest that we're getting from our task force or core is at a higher enclave. So how do I take that data, which might be on a higher classification, and push that intel picture, that COP mission orders, all the way down to the lowest level, right, to the platoons? Right now, we have cross-domain solutions that can help, but there's some data impurity issues that come along with there. So some of the data get stripped, right? And sometimes it just doesn't even work. So we don't have time to engineer it because there is no additional help. So we do a lot of swivel chairing, which requires a lot of manpower to take that data from this classification and push it down onto a lower classification like ITN. So for us, there's no servers on the drop zone. There's no large basebands on the drop zone. There's no large transport mechanisms on the drop zone. So it has to be very cloud-heavy infrastructure for us, at least for the first 96 hours. Now, when the follow-on echelons land and the larger kit comes out, then you can set up some other instances of local servers, virtual machines, et cetera. But for me, the biggest challenge is during the first 96 hours, the hardest day of combat for us, because we're the first ones in, is how do we survive while also being able to maintain a robust architecture that allows us to make decisions, and our staff and our planners and our leaders can get that data at a quick speed and be able to push out mission orders to our subordinate units.
All right, so we're hearing some similar but also different challenges across these different flavors of units, right? SWAP being a huge concern for, armored platforms, but also, you have to be able to jump with everything and be able to operate once you get on the ground. And so, curious to maybe hear your three perspectives on doing dispersed C2, right, at distance. You mentioned that you guys will be operating very dispersed. That's a key characteristic of LISCO going forward, right, is being able to do that communication dispersed across the battlefield. And so as we're talking about doing C2 on the move now with certain capabilities, going to be very, very critical. And so would love to hear your thoughts on how each of you are kind of looking at doing dispersed C2 or the characteristics of capabilities that you might need to be able to enable your units to be able to do that.
I think the main enabler for that concept is our transport capabilities, right? So that's the make or break for our formations when they're operating in dispersed areas. If we don't have that reliable transport, then we can't get that information at the tactical edge, and it gets even more challenging as we continue to push them out more and more, and then our command posts are staying more static, outside in those secure bubbles, outside of enemy long-range fires capabilities. So I think that's first and foremost.
So as I said earlier, it's the number of nodes that we can actually set up and occupy. One thing we've been doing is putting our server stacks as much as we can in the rear and putting them in sanctuary with our UHST, our unit satellite transport. So rather than using the RHN, we are putting them and using our actual division hub node and everything to land our shots and then reach back into our servers. The problem is once they're disconnected, they don't have it. So we're sending the smaller server stacks forward with each node, which allows them some disconnected capability. So when they do become disconnected, they are not inoperable, but they just don't get the most recent data set.
Yeah, for us is the same. And we probably have, our mission command nodes can be up to 4 or 5 at the division level, whether it's the assault command post, which is a very small, the first jumping unit that goes out, and that's the CG and all his principal staff, and we go out, and there might be 30 of us, and what we can carry. We potentially drop one vehicle platform out of the back of a C-17, and then we try to shove as much stuff as we can in there, and hopefully it survives the landing. If it doesn't, we have to salvage the parts that we can. Number one. Two, the other mission command nodes are completely distributed as well, whether it's the FUOPS, the CUOPS, and then the Intel cell. We have to make those displays for survivability. So for us, it comes down to, there's no servers coming forward, at least for the first 48 hours. And we have to rely on a singular domain that we can reach back to. Again, it goes back to that transport diversity, whether it's through commercial transport, MILSATCOM, leveraging commercial cellular, private cellular, whatever it is, to get back to the WAN, to get our services, right? And there's nothing front, so it's all enterprise services. You punch in the URL and whatever COP tool, chat system, aggregator that you need, you're just pulling it off a tablet. And as long as you have that throughput, we're good. The problem that we have now is just the capability. We don't have the amount of capability to support the division. Now at scale, the brigade combat teams and then the battalions have to do the same all the way down to the company. So the problem that we face now is we understand what the solution is. It's just getting the capability at scale.
Right, and 82nd being one of the more mature ITN units, right? I'm wondering if you could maybe unravel a little bit. You got into it a little bit initially, but what are some of the challenges now that you're moving that complexity up to the division level, given that a lot of this was tested, brigade to brigade, right?
So I think so ITN initially was designed more for a really tactical network, kind of battalion and below, and it's great. It produces PLI for the dismounts, which we haven't had for a long time. It has situational awareness, and you can share ISR feeds, et cetera. As long as that network, that MAN-A, that mesh network is connected, which is high throughput, which is fine. The issues that we see now is on the drop zone, we're fine. So whatever that gap that you throw us into, we're good. We're good. Clear line of sight, 4 kilometers. High throughput, we're doing fine. The division, which is pushing out to the WAN, is probably a kilometer back. But once you start pushing off and start expanding the lodgement, right? You start going into the wood line, you start securing the area for, the armored divisions to come in, follow on. That's when we start to lose connectivity. So the problem that we have is we have a self-inflicted DDIL environment, right? When you look at the scheme of maneuver and how to tactically place those hopping nodes, is like once we push into the network, we have to be, or once we push off the drop zone, it's like, how do we be creative in order to continue that high throughput? So those are some of the biggest challenges with ITN. Now there's aerial nodes that you can use. There's aviation assets that you can use to retrans, but right now we're still trying to figure it out ourselves. In the 82nd.
Mm-hmm. Yeah, and Cliff, you mentioned that you're not necessarily a C2 fix unit. For those that might not know, the parallel efforts of C2 fix and next gen C2 fix obviously being the bridge and getting some interim capability until next gen C2 comes online. But as newer capabilities have been introduced into all of your organizations, I'm wondering if you can each describe how some of these have provided enablers over some of that legacy capability, and maybe either some success stories or what you'd like to see more out of some of these newer capabilities that have provided enablers.
So for us, the biggest new capability we've gotten is really just the CPI-2 trailers. Everything else that we have is more legacy with just upgrades. So rather than the BCCS servers, which was your old server suite that hosted your Microsoft Office and your entire domain on it, and traveled with each brigade and division. We moved to TSI stacks, which is, don't ask me what it stands for, but somebody got a great name. It's the next version of your server stack. What we've done over time, though, as an Army, everybody's gotten rid of having email server. We've dropped our own domains for the email servers and a lot of the Active Directory stuff, and we're starting to move towards an enterprise solution. Well, that means that I'm using the same email everywhere I go, which is awesome, but it's not hosted locally. So as soon as I become disconnected, I no longer have email capacity. I can't have something sitting there ready to go as soon as I have connection. Outlook gives you some ability to do that and prep it. So that's an app on your tablet. I can write a zipper email, have it, and as soon as I'm connected, then it'll go out of Outlook. But now it's not sitting on a server where the end user can pack up their computer anymore. Their computer has to be out in order to send that email at some point. I think that's about the newest technology, the trailers and the transportability. So what the trailers are for CPI2, if you're not familiar with it, they taken expando vans, and any of you that were in S6 back in the day, you got the expando van service. Like, hey, let's take that. We can set up a talk in that. It'll be great. And you get it, and it's got like a heater or air conditioner, and that's it. And you go in there, and everybody puts it in folding tables, starts running cables, and tries to figure out how to use it. And they pack everything up, and they break everything when they fold it up. Well, the great thing about it is there's a network stack actually built into it. There are the routers, the switches, a TV, monitors, entire TalkNet system for your FM, HF, TACSAT, all your comms, and all your transports built in. And they have workstations built into it, so when it's time to go, you collapse the shelter down, you're ready to move, and it's about 15, 20 minutes setup time, and you can be on the move. The only problem we have right now is plugging that into the network. So once they pull up, we just got to run a cable or wireless to them, and then still rely on the old WinT systems.
It's similar to Fourth ID. Really, it's just modernization of the equipment we have on hand. And we will be soon to going through our CPI2 fielding. But we will have an opportunity to look at the ITN capabilities that Tim mentioned with our First Brigade, who's going through the next iteration of transformation and contact. So the advantage I have in my seat being in the UCOM AOR with the RAF division is that we have 310th Mountain, who's currently going through transformation and contact. And so we're using their lessons learned to understand what that might look like for the armored formations. We tend to always test with our light units and our light formations, but we don't understand the challenges that brings in an armored unit. And so we're trying to stay ahead of that and see what that can, how we can inform the working groups at the higher levels to make sure that we get the appropriate BOI for our formation when we go through that building.
Because again, as a lighter unit, they're going to have different challenges. Right.
Yeah, for us, it's smaller and faster, quite frankly. So we've had the luxury of having the capability of utilizing PLEO across our formation. We have several terminals, which is unlike most of the other divisions, and that has been a game changer for us, is being able to use PLEO and commercial satellite for that high 40 to 100 meg throughput pipe, right? And that's one way, and we're able to push that down to the brigades. We'd like to have more, down to the battalions, potentially to the companies, but in a smaller package, something you can shove in a rucksack, number one. The second thing is, I think we talked about everybody has their own box, whether it's an AFATADS box or even MMCS has its own separate tablet. So we're doing some crafty stuff with trying to virtualize some of those machines using our TSI smalls. So those are probably coming in at a later echelon, but they're still anchored into our home station mission command at Fort Liberty. And if you virtualize those machines, then I just need to jump one tablet that rules them all, right? And in our core, we utilize Maven over CPCE, which in itself has its own challenges. It is a bandwidth hog as well, too. But if you have something that has those big pipes, then you can pull up that one tablet and pull up your virtual Maven machine, and that does all warfighting functions, as well as MMCS as well, too. So virtualizing and then high throughput capacity on the transport level.
Mm-hmm. What about data? You mentioned 96 hours from the jump you guys are kind of operating. I'd be curious to hear, maybe you start and we go down this notion of being able to access the right data at the right time. I've heard in the past data being referred to as an ammo or food supply. How do you give 3 days worth of data to a unit that might be going out? How are you guys as Division 6s kind of thinking about that and enabling your subordinate units to be able to have access to that right data?
Well, for us, it's a challenge. When we, again, our problem set, we're probably not accessing that data until about 15, not even 15, I would say about 4 hours after the heavy drop comes in and we're able to pull up our systems. It's just been, it all comes down to the transport for us, is being able to access that. And then when we talk about transport and accessing all that data, so we look at transport diversity. So I got 4 or 5 different things that are resonating, that are pulling in that data, whether it's, again, through PLEO, MilSatCom, whether it's the L-band, the Iridium, and then our good old 4G, 5G LTE. And so how do I how do I determine which the best pathway, open shortest path first type of stuff, like what, we have a challenge now where we don't know, which system to use at the right time. And that goes back to the survivability aspect of it. It's like we've got 5 things resonating, and then, they become a bigger target for us from an EW perspective.
I think the biggest challenge is we have access to our data here for the division. The problem is when we add other elements, where does their data come from? The other part is, what is the data source? What is we're going to say this is the source of data. This is the count. This is what we are going to rely on, and this is what we're using for our data. That has to be identified early, and everybody has to be in agreement across all echelons that this is the data source and what can be used to count beans, bullets, ammo across the board. Because if we don't agree upon the source, if the source is the chef in the kitchen versus the supply person delivering the food saying, I delivered 4 pallets of food, and the chef saying I only have 3, who's breaking that argument? Because then you're telling the commander, I got 3 days worth of food because I got 3 pallets, or I got 4 days worth of food. And there's an argument inside the talk because nobody can validate which data source we were following.
Yeah, just like Cliff mentioned earlier in his presentation, I think it's about baselining for us, right? We are going to have access to our data when we arrive, but I have the challenge of having different types of sources across my formations. I have, and I'm looking at my team over here on the left because that's who your warfighters are right now in your breakout sessions that will be able to provide that input. We have TSI smalls, we have TSI larges, but I also have our legacy BCCSs. And that's across my entire division. And so that baseline is important, when we're going out there.
Mm-hmm. It was mentioned a couple times, you mentioned it earlier as well. Curious at a very general level to hear maybe what spectrum concerns you guys have about operating some data. You were talking about needing, AI and ML to maybe help better understand some of those issues and to kind of throttle the network when you need to. How do spectrum concerns maybe come into play when you're thinking about either distributed C2, getting data to the right place, mission command, any of those types of things?
Yeah, I mean, so we've got to relearn how to operate in a contested environment that we've, for a long time dominated. And so, having systems that incorporate AI and ML can remove a lot of the human errors, the human interceptions that have to occur at the manual level with our systems to make sure that you're not emitting during this, from this phase line to that phase line, and just, the lessons learned that we're, consolidating from the conflict in Europe. So it's all the C2 system challenges coupled with operating in a contested environment, can be overwhelming for the soldier, for the warfighter. So, the more AI, ML we can incorporate, the better. So that way we're, equipping that soldier with the best.
Mm-hmm. Yeah, but as you said, it is a very contested and congested environment with a lot of data, and that can be a lot of cognitive overload for folks that are even trained in that area.
And being able to learn that and aggregate that data and that information so we can take a look at, so we can assess the risk and the threat for our commanders, and better employ our systems.
So as the G6, we plan for the use of the spectrum, while the electric warfare team in the 3 shop is out there battling it. But who's actually analyzing what spectrum's being used? Who's planning for a diversified path on spectrum? The other challenge with spectrum is it's limited, and the enemy has a vote on what they're going to jam. We're trying to jam their stuff. So we're battling each other in that space, while at the same time we're trying to utilize it for our communication needs. But then industry and the civilian population in that area also has a vote that we can't train on it because we don't own it. And if I go out there and I try and jam spectrum right now in this city, there's going to be a whole lot of angry people in Texas because I'm going to take out the entire cell phone network because I jammed the wrong bandwidth. So training on it and then having the machine learning to be able to jam and target the right bandwidth is very difficult. And we're even working with Space Brigade right now on some of that in Fort Carson to figure out how we can do some testing and training on jamming of satellite and SATCOM out there. So we're trained as an element, but we're also getting training on our end to learn how to identify that we're actually being jammed and that it's just not a system malfunction. Because first thing, well, what's wrong with the system? You start at the very bottom up and working, and the last thing you're checking is the enemy's out there jamming you.
Yeah, for us, we in a non-permissive environment, we're not really concerned about what nation we're jumping into and their spectrum. To be quite honest with you, we're more concerned about our own personal survivability when it comes down to it. So just like the first statement I said, right capability, right place at the right time. It's not about the most bandwidth, it's about the right bandwidth and the right amount of data, so that way we can displace and not be seen on the network, that we can mask ourselves. So it could be something as simple chat, and we all go back to chat, it's small bits of data, it's you can hardly pick it up on the spectrum depending on what you're using. So we look at spectrum as either it's going to help us or it's going to hurt us, right? So when we have secured the area, then potentially we can bring in higher throughput capacities and things of that nature. But when you're there initially, it's about minimal bandwidth usage. So it's a knowledge management issue. It's a G3 issue. It's about how we fight and we scale up over time. So when we hit initial and then, okay, these are the core functions. These are the foundational core things that I need to do is just talk and chat initially, and that's all, right? And you don't have to have everything going for that because they expect us to bounce and move in 45 minutes. You don't have all your systems up then. You package it up, you move to the next spot, and then you set up in another 20 or 30 minutes.
Mm-hmm. Yeah, I wanted to pick up on this too, Cliff. A lot of the close work that you're doing with the 1st Space Brigade, what kind of lessons, maybe from a multi-domain operations perspective, are you taking for yourself and your division from a 6 perspective and a communications perspective, if any?
So there's a lot of space assets out there that they have the tie-ins, especially with Space Force now as they've separated, and with the Air Force, taking their lessons on how they utilize space and what capacities they have and they can bring to the fight. We're using that information to try and understand what some of our limitations might be in the future. If it's easy for them to take one of their space assets and jam my satellite with no knowledge, then it's going to be easy for the enemy. So that can then inform us as we do these exercises and training with them to, hey, what are lessons learned so we can move our capabilities elsewhere and how they can identify, possibly target our assets from space, see what our spectrum looks like from space or someplace else. So those capabilities are very important. We're just starting these exercises with them in the past year. So as we build this capacity, it's creating lessons learned that we're sharing across the Army.
Mm-hmm. And similarly, I'd be curious to hear any insights from the three of you on any lessons from home station training, CTC rotations, even deployments. Is there anything maybe that comes to mind, either that you three have participated in or some lessons that you've garnered from other partner organizations that you're working with that are relevant to the discussion here at all?
I mean, so being in the UCOM AOR, we talk a lot about interoperability and having having the ability to be truly interoperable, and I think we're just really behind on that. And it could be a policy thing as well with the host nation, but without going down that rabbit hole, I mean, our C2 systems are so complicated and so secured that it makes it near impossible to establish interoperability with our partners. And so those are the challenges that we're going through in our exercise. So we end up integrating more than we are doing interoperability and not overcoming our L&O packages of, sharing, having a U.S. person there to share the PLI information versus just, opening that up, to our partners so that we can, fight together.
So I will add on to that one as well from interoperability. So we're never going to fight alone, right? And four maneuver battalions is better than 3 + 1 when we're going into a joint fight with our partners. And I think some of the biggest challenges that we face from the tactical side, and some of the beauty with like the secure but unclassified encrypted networks or the overclassification of some of our other networks, is how do we, so a vignette would be a sensitive shooter where you're using a British para or a Canadian or pick a partner nation, they're the observer, and how does that go back to the firing unit within our division, right? So there's multiple things that you can look at. He calls it from voice, and it has to go from his system from voice to his battalion command post, which let's say it's OpNet Blue for the Brits. Then it has to go to their version of AFATADS, which is FC BISA, and then it has to go through a cross-domain solution, which I think is hosted in Europe. So that has to bounce all the way over to Europe, come back, switch over to our AFATADS, which resides on a SIPR network, all the way to the JADGIC at the division, then back down to the fire, whether it's a general support aviation battalion, or if it's to a firing battery, then all the way through the SIPR network to that firing battery just to prosecute that target. And if you think about all those different hops, then your kill chain is extended, right? And then there's multiple technical issues that can arise, and by then it's too late. So I think one of our bigger challenges with interoperability is partner nation, as an example, the fires kill chain for us. And we've experienced that not only at JRTC, but training with our allies. And that's just the technical side of the house, not looking at like the language and the culture aspects that are involved with that as well too.
So going along with that same technique, like we are getting ready for our warfighter next summer. And with that, it's a mission partner enclave that we're using for that exercise with 4 different nations. We began planning it 2-3 months ago, so a year in advance. If we're going to war tomorrow, do we have a year to build a network with other nations in order to conduct that operation on? It has to be plug, play, go. I argue that we should almost stay on our same network. It should be secret rail, whatever it is. I don't care what it is at the end of the day. I just need one network that I'm stable on. I've done this with 25th ID where we switched between networks. We had 3 CPXs leading up to a warfighter one year, and every single exercise was a different network that we operated on as division staff. It becomes very hard learning and building capacity when you're swapping networks every few months. So we're building our MPE enclave right now. Why is there just not a simple cross-domain solution that is easily implemented that allows our data to flow between networks, where our data is actually tagged, labeled, and it becomes releasable very easy and early on at the end user level, that you don't have to think about it. The data can go to that other organization. The Brits can get that AFATAS data. We can receive theirs because it's all labeled properly with the correct classifications for sharing. It's a higher level problem that needs to be solved by somebody that cannot correctly identify types of data and what can be released and what can't. But then you implement the solution down at the lowest level, which allows you to move between networks with somebody sitting right next to you. Because if a foreign nation sitting right here, I want to communicate right there with our 2 networks touching without going all the way to cloud into another AOR to pass that data across.
Well, we have a few minutes remaining for questions. I'd love to bring the audience into the mix here for some of your really important and informed questions. I saw this one right up in the front here.
Hey, good morning, Mike Haggard from AT&T. So all 3 of you talked a little bit about 4G LTE, 5G, using cellular, and you talked about it kind of in the context of being your backhaul to get to. Can you provide a little bit more context, a little bit more information about how you use it and how you would like to use it in the future?
So for 4ID, we're working on getting some cradle points so we can use them as an alternate path. And the idea would be that we can then go and grab onto anybody's network if we go to any country. Problem is, you get there, then you have to figure out what the network is. It might be AT&T in this country. It might not be. It could be Verizon. It could be any other third-party network that we don't have an affiliation with. How do you contract, get those chips, get on their cell network without breaking into their cell network? And if we're at a full-blown war, can we break into their cell phone network and take control of that host nation capacity? Because if somebody comes here and we're at war, do we want them breaking into our network, or is that a different level of war when that happens?
So we have a very robust cellular network within the 82nd Airborne Division. I would say probably one of the primary in our pace plan for transport, as far as the battalions and below, cellular is very high. All of our EUDs have cellular network capability. And it's a great mesh network. It provides high throughput, but it in itself has its own challenges. When we're training in the United States on Fort Liberty, it's great. Everybody's getting data. We're meeting the objectives. We're at the task. We're passing ISR feeds, et cetera. But what keeps me up more at night is if we go somewhere else, CENTCOM, EUCOM, PACOM, AOR, as the immediate response force for the globe, we have to do, that's part of our spectrum analysis, is where we go, where potentially do we go, is there any type of cellular coverage? But then I got to ask myself, I got to balance that between, there's some inherent vulnerabilities that come along with using commercial cellular as well too, right? It's both detectability and geolocation whenever you're using host nation commercial cellular networks. Because because once you're on that network, you're roaming, right? And once you're roaming, you have things that are called IMEI numbers, right, which are associated with AT&T, Verizon, et cetera, and then they're not masked anymore, right? So on those networks, it becomes a vulnerability for us. So what we struggle with is, yes, the technology is great. We all use it. Everybody here, it's wonderful. From a mesh perspective, is just when we deploy with it in real world combat, is it really a viable source? And I'll tell you, the 82nd Airborne Division has kind of gone away from that as being more of a primary, as the easy button is to use cellular networks, and kind of pushing that down. In the event we need to use it, we will, but we'd rather use something that's more survivable. Or also leveraging private cellular networks, which is also helpful for us as well too.
5G.
Yes, sir. On private cellular as opposed to commercial cellular.
I would say that it's our alternate means in the PACE plan, but quite frankly, our warfighters would go to our cellular networks first in the PACE plan, just because of the complexities with the satellite, transport capabilities that they have. To add on to Tim's note, so for us in the AOR, sometimes that is the more reliable transport capability because of just where we're at. The satellites at different angles don't necessarily connect, and they're not reliable, and they're intermittent, and the cellular capabilities tend to be the most reliable, and so we do view that as a reliable alternate source to our transports.
I'm Vik Patel with Datasoft. Have you considered the NSA's recently released Tactical Capability Package solution for CSFC, which will allow you to use non-Type 1 radios, as well as Type 1 radios, as well as the TIG, the Tactical Internet Gateway, but at the same time extend the tactical network at the edge to the dismounts using just their smartphones and collect sensor data? We actually have components on the components list for the Tactical Capability Package solution.
So I'll say the CSFCs, probably not what you just described, is part of my kit bag as well too. So I know that if I hit the drop zone and I can get a cellular network, I can tunnel in, and within 5 minutes I'm on my tactical network. It sounds well. Have not used it yet too, but I'm looking forward to. I understand CSFC is something that we're really interested in expanding our capability for. That exact reason that you said, is being able to get the tactical internet immediately through tunneling through and reaching those secure services.
We've used a couple different CSFC solutions for anywhere from laptops to tunnel in to your wireless solutions that are out there for a wireless LAN. Different implementations, we have a couple different things that we use.
Mina Tawadros, USF Institute of Applied Engineering. So my question will be two parts. First one is about the cellular networks itself. So are there any consideration into a small portable cellular network deployment depending on the circumstances of the mission, using more of a satellite-based backhaul, as well as any other untraceable backhaul systems? That will be the first part of the question, and accompanied with that, if any has been trialed, what are the technologies, if it's unclassed, that has been used? The second part, going to the jamming environment of jamming signals. I've been exposed to jamming processes before, and most of the time we are dealing with the lower 2G, 3G jamming, though we have the capability currently of jamming even 5G, 4G, and we might be prepared for what comes next. Is that also being like, per the information provided, we don't care much if we are in a hostile environment, if we jam the whole thing. We just care for our people. But in the meantime, using our unused spectrum or Army reserved spectrum across the board, is that something that we can poke in with minimal jamming to say, as well as looking further into ciphering our communication, even with like, hard to say, like even Starlink. Thank you.
That's a lot to unpack, but I'll sit there. I would love to get my hands on something you just described, right? From a the cellular network is great. It's better than a TSM network. 4 kilometers turns to 14 kilometers, right? Especially if it's in a vehicle mounting capacity. I know capability does exist. For private cellular, you're also able to mask yourself, and it's also smart to choose the correct band that's available for you, and then having some sort of link to a transport system that can get you to the WAN, right? So that's something that we have identified as a need. We have not used it from an application perspective. I know some soft organizations have kind of dabbled into some of the private cellular networks, but nothing that we've done with the 82nd. But definitely something very interesting that I think would solve a lot of issues for us when it comes to range and survivability.
Yeah, I don't want to dig too much into which spectrum can be used for what. It is allocated what is reserved across the DoD. A lot of it has allocations for different uses for different things, and that is a huge problem for the spectrum analysts out there to dig into on what they could jam and what they can't. At the division level, that capacity and those decisions, though, aren't at our level.
All right, we're going to go in the back over here.
Hi, good morning. Wei Escala from Exchange. So I have a question for Clifton and also for Audrey and Timothy. So Clifton, when you said you need that single network labeled and classified, I would love to understand what do you mean by labeled, and also if it can be proven to be the single source of truth, do you still need it to be labeled, and if so, why?
So when I say labeled, I was talking about like which network it is, whether it's a SIPR network or a MPE network, whatever type of network it is, and whatever classification label is put on that network. To me, it's agnostic as to which network it is. It's just I have one that I'm working on, and then all the data is tagged or labeled in a way that says it can ride on that network, but it can go lower. What our struggle is we have a way of taking data from the lowest level, from that person working at the unclassed level, and passing it up and making it secret, top secret, and keep adding little labels to it and make it this super classified piece of data. What we don't have is how do I send that data back down and break it back down? So as you aggregate the data, and you can aggregate it too, but aggregating it becomes a higher classification a lot of times. When you deaggregate it, how do you break that back down to a lower classification? Because everybody sees the highest classification tag that it got at one point, but then you have to break it back down. So that way you can pass it back down through the networks to lower classifications. If there's 3 classifications in the network, I can work with that. When you start adding 5, 6, 7, 8 different networks, it becomes harder, because if I need a partner network to talk to country A, a different one for B, and a different one for C, because State Department is never going to have an agreement between A, B, and C to share their data in the same way they share with us. So you need a different network for each one to communicate on. It becomes hard.
And then leveraging technology as opposed to a human in the loop that has to take that data, whether it's an FDO or whoever that pushes that data down, which is also can stall the information flow as well.
Yeah, and the earlier discussions were based on interoperability, what's releasable, and removing the human. intervention piece and just tagging it so it can go where it needs to go when we discussed, the sensor to shooter concept.
I think we had one more. I think this is going to have to be the last question over here.
Hi, with quantum interface. So I hear cell as a common theme, but in terms of radio usage, two questions. One is, have you worked with SOCOM with the HEAC project? Because that's using a text-based string that puts out kilobytes. It doesn't light up the sky, and it's been proven for text messages, RGB, ATAC information, and other things. The second thing is, how would you end up testing new forms of like UDP instead of TCP to work across the same radio networks for 100 times, 300 times faster information? And how would that be tested right now? How do you get into the system to actually test it for operators to see how fast you can integrate something that exists today?
I am not smart enough to answer that question. However, it sounds fabulous. I would love to get my hands on
Have
it.
not tested
and
it.
no.
And it was HEAC, you said?
HEAC.
HEAC.
H-E-A-K.
So we have limited testing capability for demos and stuff a lot of times where we can do the frequency requests and get different things to test and validate. I know for the PMs and a lot of those bigger ones, it goes to an Army level testing. I believe they do it down at Bliss for the annual exercise they were discussing earlier, how they do an annual validation of equipment.
And I think, sir, you brought up a point that, although we're all Division G6s, this is the first time I've spoken to them in a while. So needless to say, we've got a lot of stovepipes of excellences across the department, to include SOCOM. And that's where, we struggle with, we're busy fighting our fight with what we have in front of us. But, we having an integrator that can bring in all this great technologies, these good ideas to help everybody writ large, all the ships start rising together.
Excellent. Well, unfortunately, we're going to have to leave it there. Please join me in thanking this wonderful and esteemed panel.
Yep.
As our panelist and moderator, thank you. You did a great job. Thank you, guys. Get ready for the next panelist. We wanted to make sure you guys had a warm welcome to Austin. So some of you might be lucky to get a little thing from us. Under your seat, you might find a hand sticky note. If you have one of those, my counterpart, if you have one, let us know. We want to make sure you have a boot and an annual report from Army Applications Lab. The boot should help you at the social networking event over here in the back. And the annual report, you'll be able to enjoy this evening while you're in your hotel room. Do we have another one? Oh, right over here in front. Right here. Yes, ma'am. I think I got one more. We up on the top, Ari? Ari on the top right. Huh? Okay. You get the last two. I think over here, it might be on the floor. Pretty sure there's a sticky over here. If not, or just give it to somebody that's never been to Austin before. Who's new to Austin? Up here in the front, in the back. Like I said, make sure you have these for the networking event. You'll get to read a little bit up on Army Applications Lab and then enjoy a nice beverage of your choice. So our next panel that we're about to bring up is going to be the bend but don't break. How do we maintain resiliency with a digital network, a digital platform? We've seen this in the past year with news, different companies shutting down airlines, medical facilities. How do we maintain a resilient network? Netflix, the Mike Tyson thing I told you about before, we had glitches, and we had that Black Swan event. So let me introduce our moderator who will present the rest of our panelists. You have Jim here, from a senior risk manager from Amazon. He'll be moderating today's the next panel discussion. Please welcome him.
All right, thanks, Sam. Appreciate it. All right, thank you all. Appreciate it. Try not to talk too loud. I'm not used to being mic'd up. I'm used to being able to project in a large room. So I apologize if I start blowing anybody's ears out. Let's see. Real quick, what I wanted to do is just give a little bit about my background. So I am a senior risk manager at Amazon. What I do is I look for innovative solutions for mostly technical issues in the security and loss prevention space. I work for the director of security and loss prevention for the AIMers, which is Canada, US, Mexico, and Brazil. Kind of ironic that they were talking a little bit this morning. I'm actually integrating ATAC into our Global Security Operations Center currently. And so it's funny to hear some of the same technologies. Prior to that, I did 37 years in the DoD. 22 of that was in the Army. Retired as a functional area 53. Information systems manager. Then I moved into OSD and DISA, working in defense continuity and mission assurance, as well as I was the portfolio manager for the National Leadership Command Capabilities portfolio. That is mostly senior leader comms, command and control, continuity of government, and special access program IT stuff. So with that, I want to open with just a few kind of conversation points, and then I will have each one of my panelists introduce themselves. So we talked a little bit about this, bend, don't break, right? What is that? Is that a valid assumption? What's the question that we're actually asking? Are we coming at that correctly? There's a lot that goes into that, and of course, a lot that goes into the resilience itself. Right? So how do we consider all aspects of that in our resilience planning, right? It's not just systems, and we've heard common threads. It's systems, it's transport, it's personnel, right? But we got to make sure we take in all of that for both known and unknown scenarios. And is it more than just the textbook answer, right? We can all go out and find out what is the definition of resilience, right? But what does that really mean to us to be truly operationally resilient? How do we consider the people, processes, and technology for this outcome? And then, how do we, like when they just mentioned about black swan events, right? How do we maintain operations when things don't go well, all right? One of the things that I used as an example was CrowdStrike, right? Here we are in a pristine environment, right? We're at home station. We've got robust bandwidth on our networks and what have you, but then a couple of lines of code brings down a significant number of systems across the government and industry, shutting, like, say, Delta Airlines down for several days, right? Think adversaries would love to be able to have a capability like that, and we did it unintentionally. How do we prepare ourselves for those kind of things to ensure it either doesn't happen or that we can very quickly recover from that? And with that, what I'll say is, I'll start with my left. Brian, if you want to go ahead and introduce yourself, and then we'll go down the line, and then I'm going to ask a question of you. Give a little bit of your bio and tell everybody about your background.
Okay, awesome, thank you. Yeah, so my name is Brian Chamberlain. I came to the Marine Corps in 1998 and recently retired as a communications officer in the Marine Corps. I was with the MAGTAF staff training program as a communication information systems branch head. And then from there, I rolled over to my first job outside of the military was SolarWinds as a DoD sales manager. So some of you may have heard of SolarWinds probably, but yeah, that's where I came from. So a little bit about myself. Yeah.
Great. Ian?
Yep. Thank you. My name is Ian Eischen. I'm the Director of Public Sector at Illyria. I spent 23 years active duty Air Force, mainly on the intelligence and special operations sides, and then spent the last 10 years kind of doing developmental tests, Project Maven, a lot of the AI on the software and hardware stacks that we were deploying downrange, and then some work with In-Q-Tel on the open source side of things. With Illyria, I'm kind of running all of the public sector side, both civil and defense, and really happy to be here.
Great. And Glauber?
Thank you, Jim. So I'm Glauber Costa. I've been an engineer for the past 25 years by trade. Initially, I was one of the core contributors to the Linux kernel, where I work with things like file systems, networks, storage devices, and etc. Around 10 years ago, I helped design a database focused on the petabyte scale workloads. And now I am the founder and CEO of Thurso, which is also a database company, but focused on problems much like the ones that I saw being mentioned here today, of how do we keep data working offline, how do we partition data in a way that can be put into mobile devices. Of course, we've been doing this from an industry perspective, but I'm very excited to be here learning about the military problems.
That's great. And I will say it was really nice to hear some of the things that came up during the keynote and the prior panel, because I think we're going to be consistent in our conversation. We're going to talk about requirements. We're going to talk about AI. We're going to talk about data. And we're going to talk, let's see, well, I left one off of there. Transport services, of course. Again, very consistent there. So I don't want to put everybody on the spot, but what I'm going to do is I'm going to ask you, and we'll go ahead and start from Glauber back this way now, to provide give me an anecdote or a brief user case of a situation that you were in where everything went wrong and what you did to recover from that, but also kind of what were the lessons learned both personally and either professionally or from your company's perspective?
A lot of things go wrong all the time, right? So just and look, we had a situation recently where so just to be clear, are we talking about like a professional situation or a personal anecdote or?
Either one, whichever one you think is most appropriate for the audience.
Yes. Gosh, where everything went wrong?
Sure. Yeah, a situation where something basically fell apart and you were looking to, I'll say maybe a rapid response to restoration or a situation that was evolving rapidly and maybe you didn't have the appropriate tools at that time, but this is what we did to kind of get through it.
So we did have, I think one interesting anecdote was actually in DC at my previous company. So that's this database designed for petabyte scale ingestion. I won't disclose the name of the customer, but we had a customer in DC. I was actually flying to see them. And so imagine that we had a cluster of nodes. It's a distributed system, right? And one of their, at the time that I was there, so I was just there, it was a sales interaction. And as I arrived there, they notified me that one of their engineers, just by accident, types the wrong command. So that happens and destroys. So again, for context, the database there is designed to be always up. But to be always up, you have a certain guarantees. I mean, you have a certain number of nodes that are operating correctly. And then one of their engineers just runs the wrong command and destroys 2/3 of the nodes. Wow. Right? And this is when as I'm arriving.
High stress environment now.
So now I have this, the challenges were multiple at the time because first of all, the conversation shifts from how do I negotiate a contract to how I help them get out of the situation, right?
Right.
And I think I had a lot of lessons learned, on a personal level of how to present, how to negotiate a stressful situation like that. I was on site. It was just if this happened, and I'm seeing this terminology being used here at home base.
Right.
If that happened at home base, I think it would have been a different thing because you have the engineers on our side that we can essentially lean into. And my background as an engineer actually come in handy because here I am, right, a representative of the company. Like, okay, so now I have to help you guys get out of the situation, and then which essentially like all of your data is essentially lost. We found a way to get out of there, but like it's localized versus a CrowdStrike-like thing that happens because human error. So that's always the lesson, right? Like just you design your systems. You can have the perfect system. Every system will have its guarantees that are built upon. Like in this case, like you have to have a certain number of quorum of entities in the distributed system up so that this thing can be always on. But then how do you defend against like somebody just makes a mistake?
Exactly.
So how do you restore from the situation? And how do you translate from that into a situation in which now this is a win, right? This is not like, look, something is lost. You have to admit that something is lost. But what is the best next thing? Which is, okay, so what can we restore? How can we get from here? And put your best face up. So this was probably one of the most stressful situations of my professional life. And
Sounds like it.
Yeah.
Anytime you have data loss or potential data loss, it gets very, very stressful quickly. Ian, any similar thoughts?
Yeah, I mean, there's tons. Anybody who's done a couple decades, I mean, there's a lot of veterans in this room, and so anybody who's spent that much time in the military has spent a lot of situations that everything goes wrong. Some good examples that I think are relevant to this conversation is I can think back to multiple operations, in Iraq, Afghanistan, and the Philippines, where we had a very nice PACE plan. In all of our planning and our step briefing or our mission ops briefing, depending on what type of ops center we were in at the time, there was always this really nice chart of exactly what we were going to do, and if that didn't work, what we were going to do next. And usually that worked well. But most of the diversity that we had at the time, our primary to alternate was usually, beyond line of sight to maybe another beyond line of sight frequency. It was the exact same radio, but maybe a different frequency. The contingency was maybe we go line of sight, maybe on a 117 Golf or on a 148. And really, the diversity became in the hardware. It was the 117 versus the 148, or this primary frequency versus alternate frequency. In every single one of those situations, I can't remember a rotation to Iraq, Afghanistan, or the Philippines where host nation cellular was not the emergency, whether it was on the plan and allowed to be on the plan or not.
We're going to talk some about that too.
But when things are happening and all of a sudden you can't get comms, and in order to either execute the mission or to make sure everybody's all right, you have to get comms. You always go to emergency cellular, even if it wasn't on the list. And so building that in from the very beginning, so it was great that we heard that from the two sessions before, that network, regardless of whether it is clean or dirty, is all going to be part of it, and we need to plan on that from the very beginning. And so I think there's a lot of things that are going to be different, and whatever the next conflict is, I think that's something that's probably going to repeat itself.
Yeah, and PACE plan is critical.
Yeah.
Brian?
Yeah, so I think it was around 2013 timeframe. I had just gotten off the Marine Expeditionary Unit, and I was assigned to U.S. Fleet Forces Command with the N6 there. And I had heard some rumblings that something was not going well on the watch floor. And it's pretty green at the time. I went down to the watch floor, and the Iranians had broken into the NMCI network, impacting over 700,000 users. And they said, good luck. Here's some spreadsheets that they had printed out. And what am I supposed to do with these? Well, I want you to call the subordinate units, and we're gonna systematically take these things down. I don't even think I could spell systematically at the time. But so I'm looking at these spreadsheets and calling folks up and reading off the identifiers of each system, whether it was a router, switch, whatever. And we don't have that. I said, no, the spreadsheet says that you've got this on here. And it's no, what you've got is this. And so here we are reconciling spreadsheets, and I'm at a 4-star level. It was a disaster, a complete disaster. And so that really launched out Operation Rolling Tide, where we have CAC log-on enforcement and so forth. And I think that prior to that point in time, when we looked at the IT cyber domain, we didn't really see it as a battlefield at the time. And I think that after that event happened, it really woke a lot of folks up. We saw that here's a critical capability, right, that was absolutely necessary for, providing the combat power downrange. So I think that the Navy did an outstanding job of recovering from that. But, the lesson that I learned from that, in fact, I felt pretty passionate about it. I wrote an article, and we went out to Estonia to present it. But it was really about how can you defend this battlefield, this new battlefield that we've defined, this fourth, fifth dimension, whatever, if you can't see it, right? If you don't have a common operational picture of what your battle space looks like, it's not going to work out very well, and simply having spreadsheets just doesn't exactly cut the mustard. So, yeah, that was, I think, probably one of the key lessons that I learned. So.
Yeah, I find it interesting that in this day and age, we're still tracking a lot of stuff on spreadsheets. It's very interesting, of course. Obviously, from a, I'll say, financial accounting perspective, that's a great tool. But from what we do in the day-to-day business and tracking stuff like that, I find that almost ironic, if not frightening sometimes. Just give a quick anecdote myself. It was a Friday night getting ready for my son's high school football game, and I got a call that one of my key sites went down. Very critical site to national security. And we had to immediately get into troubleshooting mode to figure out what was going wrong, why the site went down. The systems were up at the site, but couldn't communicate off-site. Long and short of it is, it turned out that a crypto went down. And okay, quick and easy, right? We replace out of crypto, fire it up, get the key in, boom, off we go, back and operational. One of the questions that we had to go back and look at is, why do we have a critical national security site that only has a singular crypto device? Why are we not running things in parallel, right? So what we did is we went out and we started looking at industry to figure out what other companies were doing. I actually went and visited a satellite company in New Jersey, and they're just a for-profit company, and everything that they deemed as critical in their stack was 3 deep minimum. And I said, okay, we don't have enough redundancy built into our systems. So we had to kind of take that, go back and look at all of our critical sites and ask, have we done the right amount of resiliency? Have we built it into it? And the answer was no. Some we had, but many we had not. So unfortunately, resiliency tends to be an afterthought. So one of the things that we're talking about here is more like, how are we more forward-leaning and starting to bake this into the cake, so to speak. So any additional thoughts before I transition?
Yeah, no, I mean, that's a really great point that you bring up. You know, when we talk about resilience, it becomes an afterthought. Usually, once we experience the impact, right? We know what the risk is and what the impact is, and it's easy to do that in hindsight. When you've got the advantage of clairvoyance,
hindsight's always 20/20 still.
But I think, one of the things that's critically important is that, before you get to that point, really doing a pre-mortem, and that's one of the things that I would have my team do is, bring them around and, we would have them come up with the most ridiculous scenarios that we could possibly think of, right? And then kind of walk the dog back. How did we get there? How did we get to that point? And really sketch this thing out, on a whiteboard, and then build in contingency plans as if it's actually going to take place. And, and I think that that's critically important. If you're not doing some kind of pre-mortem and looking at it through multiple angles, you don't want to look at risk and impact on the back end. You want to kind of do it on the front end. So
yeah, indeed, a little bit of the like
you have
known
time
and
to
unknowns.
address those issues before they happen.
Yeah, exactly.
Lower stress.
The clear mind. You can sit down when they happen. Sometimes, and it's funny because from my perspective as an industry professional, compared to your stories, I feel a little bit ashamed. Nobody dies usually, like when stuff like goes wrong, but still, it's a very stressful situation. And having 30 minutes to think about a problem yields very different answers than having 15 seconds to think about a problem and come up with an action, right? So everything that you can move from before the action, right, I think improves resiliency in the long term.
Totally agree. Ian, you want to add anything to that?
No, I think they covered it.
Okay, great. Just want to make sure, getting everybody an opportunity to jump on in. This one's probably going to go a little bit more towards Glauber here because of what you do and some of the interesting tech and Turo. Torso, I apologize. What question I crafted up, data underpins everything we do. How do warfighters ensure they maintain access to the data that they need to make critical decisions and when they need it? And when they're disconnected, or let's just say DDIL environment, of course, disconnected, denied, intermittent, or limited bandwidth. Data-centric warfare requires continuous access to authoritative data. What happens if, despite all the efforts to keep networks running, they still fail?
Yeah, so as I said, we've been in this problem of how to make sure that data is offline for a while now. And for context, there is an industry push to see that happening for a couple of reasons. One of the reasons I think is very similar to what we see in the military environment, which is privacy. Right? So if I want to make sure that certain data is incredibly private, the less that data travels into the network, the better. So we're seeing this now, for example, with the rise of AI agents. You have some people are essentially telling their entire lives to an AI agent, so they can. So using this, we're starting to see people using this as therapists and other. So you don't want this data if you can avoid going around the network. And I think it's similar for some classes of military data. You see pushes in the industry to see that happening for performance reasons, because that data, if you don't need the back and forth, it's always better. And you just have people who want this working offline for a variety of reasons. We're actually working with a company now that is looking at our technology for prepping reasons, right? Which I guess is very similar. So if everything goes down, societal collapse, whatever, I want to make sure that those things keep working. And what we learned from this is a couple of things. First of all, it is very hard to look at the existing legacy systems that were not designed to work this way and make them work that way. Because then what you end up having to do is emulate the network layer somehow. Is the most you can do sometimes is like compress those things so it can work in restricted bandwidth environments. Like working offline is very different. So you have to architect your systems that way. But the interesting thing that happens is the contingency plans become very different, because the contingency plans before are like, what do I do if I don't have data? What if I do if I cannot operate a database, which is how data is centrally stored? But now it becomes, what can I do and what should I do if I'm operating with outdated data, which I believe it's a better, it's just a better place for you to work from. So it's better to work with data from yesterday than to work with no data at all. Like, because if you have an online system, if you have a system that depends on being online, this is your failure scenario. A failure scenario is like there is nothing that I can do with this system. So look, we're looking at a lot of those problems, and I think the main conclusion that we've been driving is you don't have to forget everything you know. You don't have to operate from different engineering principles or anything like that. But it's highly beneficial if you can take a step back and a fresh look and design a system that can work with those failure modes.
Great.
I think we end up talking about data as this one thing that exists. And so data exists for all operations, and so we need access to all the data. And I think the government approaches it in kind of a contradictory way. There's an idea that you need access to all the data. At the same time, and all this data needs to be saved. Every image, every sensor, every piece that comes off of any sensor or any thought that we have. The problem with that is the government is not also willing to spend the money that it costs to store that data. So those two things are separate. You don't normally have that issue in industry. At the same time, data is, while the data itself may be static, it's a place and time, it's a piece of information from a sensor, it's not all actually necessary. Fire data or fire's data is very different than intelligence data. They can be used together, but often all you need is the insight from the data. And so the ability to stream images back and forth, we got used to doing that in Afghanistan and Iraq, but we actually don't need to do that every single time. With Project Maven, when we were building that, we were really trying to create insights from that data. That insight is very small. It's a couple lines. You could do it in bits or in very small amount of bytes. And so you don't need the entire thing. And so some of it is a mentality shift. If you also think about all the structures that hold that data, those are not single places in time. They are living, breathing pieces that will change based on the environment and change based on the needs of the warfighter. But we often get stuck in this. I built a database, and then here's my ICD, and I spent so much time building the ICD and the MBSE diagram to catalog my data and to catalog the process that I don't actually have time to take advantage of the new insights and the new things that I'm learning. The company that I work for, the entire company came out of Google. Day one, we had 25 engineers from Google because we pulled out our IP and our teams from Google X and stood it up as its own company. And it was amazing to come from the government and building JADC2 MBSE diagrams to go into industry and then find that thousands of databases at Google and there's no ICDs. Everything is infrastructure as code. Everything changes. You just need to have a way of talking to each other. So as one business unit or one team or one part of the branch of service changes the way that they structure the data, well, then everybody else knows how to access it. And so by thinking through some of these things and actually deciding...
Is it me?
I'm not sure who that is.
I don't know. But
I'll take the blame.
Yeah. But I think some of those things, some of the pieces, the things that we want to do in our heads and the things that we want to do in the mission don't often fall into the cultural plaque and the cultural norms that exist within a lot of our engineering systems and the way that we structure and the way that we buy. And so it's moving forward, but trying to move those forwards or both forward in tandem, I think could be enormously helpful.
So the takeaway is that we're still bad at doing documentation, is what you're telling me.
It's no, because then the answer to that is do more documentation. And I don't think that
Yes.
documentation is necessary, or at least in the same way that we have been doing it. But it's being willing to take some risk on certain parts of that and exploring some of these newer ways of doing things. And then really thinking about what do we need. We do not need all the data. We need very specific data at very specific times. And we need the flexibility to change that idea of what data we need tomorrow because something new will take place.
Yeah, totally agree. It's hard to get people to understand that concept of what you're doing. Let's just say in garrison is not the same that you're going to be doing out on the tactical edge, even though you'd think we'd be very good at that after so many years of doing active combat. But no, we still want to have access to all of the data that I have back at home station, and that's just not realistic.
I'd say we got really good at that type of active combat.
Yeah.
We get really good at one type or the other, and then the new thing is going to be, it's going to be different. We'll be able to take advantage of some of those lessons, but it will change.
Brian, you always operate disconnected, right?
Yes.
Marine Corps operating with the Navy and what have you. So give us your thoughts there.
Yeah, so, I think, it's about operational resilience at the end of the day, and it's not necessarily IT operational resilience. It's about the capability of a commander to bring combat power, right? To bring a lot of combat power forward. So we kind of have to start there. Over the years, the appetite for data has just grown exponentially. And so I think, as technology has increased, this information management model, right, where it's noise at the bottom, we turn noise into data, data into information, information into knowledge, knowledge into where our decision space is, where the commander is, to wisdom, right, where decisions are actually being made. And so with the ability to suck out more data, whether it's intel or whatever, I think what we got to do is we got to get better at deciding what data is actually critical and which data isn't. And I would start with number one, the operating off mission command, by commander's intent. I don't think that we should ever try to replace this idea of commander's intent with technology. I think that's a fool's errand. But we certainly have to, do a better job of picking and choosing what information or what data rather is actually worthy of information. So,
does AI play a role in that?
I think AI can certainly play a role in it. Yeah, absolutely. There's still got to be a man in the middle. I mean, I can't blame AI, right? I can't hold AI accountable. We need people and hold them accountable ultimately. So I think that there's always going to be a man in the middle somewhere. But yeah, I mean, AI is something that can certainly help us out.
I think when we started seeing LLMs and generative AI as a whole showing up, the joke started to be for like all computer programmers, you're not going to have a job in 6 months, right? And all of that. And I knew, of course, from the start that this was a non-issue. But one of the areas that I'm seeing generative AI be successful the most paradoxically is exactly in writing code, which is a super interesting phenomenon. But what is also becoming very clear is that you will never have that model writing code that works to a certain extent, that can do in the pyramid that you showed us is, for example, that might work in moving signal to data, but it doesn't work in the higher layers of the stack, is it?
I don't know who it's Is it? Apologize, folks. Small technical issue. I don't know if the folks.
Well, we're going to be operational resilient and just power through it. So
that's right. You try that, Glover. If it's not that, you.
So if it stops, it means it was me.
You're right. If not, it's definitely me.
If it doesn't stop, then. But the interesting thing there is that what it's becoming very clear, what you're seeing in the industry, for example, is that you now have AI being built into the IDEs that software developers use to develop their code. So it's exactly that. Like at the lowest level, you can get AI to summarize information. So that can be used at the lowest level of the stack. But in any higher level of the stack, what AI is doing is assisting you to achieve your outcome, right? So all the way when you get to the highest level, then it plays almost no role. But all over the stack, it's like it's a diminishing role, and the person in command is always the one doing it. And I think this seems to me to be something that is true across anything. It should be true in the military even more, because lives depend on it, like as it is in software development, as it is in any place in the industry.
So do you think with what Glauber just said, given that the obviously wider proliferation of AI tools, do you think we can use that in resilience planning? Or do you think you can use it in doing analysis of our networks to look for those single points of failure or perhaps weak? I caution using the term vulnerability because obviously that has a lot of different connotations. But in this case, I'm talking about from a resilience perspective.
I think there's a ton of things you can use to help with that. So I mean, essentially, when you start looking at a network full of nodes that are constantly moving through time and space and with weather in between, I mean, really, you're solving a very intense graph neural network. Everything is moving. There's a lot of different candidates. There's a massive candidate graph of potential relationships that you can create. And it's very different from a standard SDN, where you've got one of 16, paths on this switch or this router, or one of 32, and they're all very fixed. And then again, you don't have weather to contend with, so you're not having to analyze dB loss in between all of those. But you've got this massive graph neural network, and it's a problem, and it's something that we work on every day. And so there's one side there that you can use to actually solve the network. Stand up the network and collapse it based on a bunch of different needs. There's another side where you can use artificial intelligence solutions to then pattern match against past networks and figure out why things didn't work. And then there's another side when you add the LLMs to play, which allows you to actually query really interesting data sets and build ideas off it in a way that you don't need a bunch of training. The amount of data that we can pull at a secret or a top secret system when we're talking about intelligence fusion, instead of me having to go in and build my own models, it's the same way we used to say Boolean logic for our friends or for the next shift to make sure that they could actually query the data the same way we did. The LLMs help us with that because we're able to take all of the knowledge that maybe an experienced analyst or an experienced radio operator has and able to pass that down to a brand new person so they can come in and say, what should I be looking for? What patterns exist? What anomalies exist? I think we do run into issues when we think about AI and ML as one thing, as opposed to different types of artificial intelligence that can be used in different types of scenarios. And they all require different amounts of swap. They require different amounts of time. But as we start looking at what needs to be on the edge and how much swap do we need on the edge for that compute, we're just going to see more and more AI solutions being used, and then we just won't talk about it in the same way. There was a time where every new acquisition had to be cloud. Like we would say, we want this capability, by the way, it needs to be cloud.
Right.
And then now we say, we want this capability, but it has to be AI-based. And that's because usually the funding came from some sort of...
And still hosted in the cloud.
Still, it could be, but you see a lot of people actually going back to an on-prem solution or a hybridized cloud solution. Absolutely. Where they can change when necessary. But when we focus on the AI-ness of the product and the cloudness of the product instead of focusing on the capability we want to provide, and maybe that capability can be provided with an artificial intelligence solution, maybe it can be provided through a very basic traveling salesman or something really easy. It doesn't require any fancy AI. It doesn't require an LLM. But when we focus on the output, it allows industry to come and try a bunch of different things. Instead of saying, you know what, I have to use Llama and I have to push it into this box and kind of shoehorn in order to capture this money or to capture this so I can be evaluated correctly and capture that acquisition. And I think in certain situations, it leaves us out and it leaves different communities and companies out of the mix.
There used to be a joke in the startup scene, which is when you're raising money, it's machine learning.
Always.
When you're implementing, it's linear regression.
Always.
So just think of
this. Brian, do you think that extends to the tactical edge, though, given the conversations from Glauber and Ian? Do you think there is a realistic, I'll say, tactical extension of these tools, or is that going to be more of a, I dare say, rear echelon kind of capability? Right? Has the somebody from, I'll say, one of the infantry brigades at the 101st is out walking patrols somewhere? How would these resilient AI tools, if it's realistic at all, be of value to somebody out there on that edge?
Yeah, I mean, that's a great question. And I think that, never say never. We want to exploit the capabilities that we have to the greatest extent. But I don't think it's ever going to fully replace the individual warfighter that's downrange, as long as we have, human beings downrange, making decisions. It's me. It's fine. As long as we have, humans downrange making decisions, I think it's important that we put things into perspective and understand that AI will continue to be a capability that supports us rather than something that we are wholly dependent on. And I think that that's something that we've got to, take into consideration. As I, looking back on building these expeditionary kind of like architectures, whether I've got a jump kit with me and I'm rolling forward into an unknown location, going through that iteration of how do we build it, what could go wrong, like I was talking about doing a pre-mortem exercise, going through that iterative process, each individual gains, in a way, as they imagine it, an experience of actually doing this. So when it happens, they're not reliant on AI to make the decisions for them, but rather it's kind of a muscle memory that's been built into, how they actually respond, if that makes sense.
It makes perfect sense to me. I apologize. I think it's actually me when I'm turning my head. Yeah, let's try that real quick. I apologize. I don't want that to be a distractor to the rest of the conversation. So,
Nope.
I think it's check. Okay. Yeah, we're good. Thanks. So, a lot of great conversation. The issue for me, and I heard this in some of the prior conversations, I missed a little bit of the previous one, but it caught the beginning. Comes down to me for transport, right? We can have a lot of power and resiliency in our systems, and I'm talking power as in robustness, not necessarily power. Good conversation with Charles back there earlier about power. But a lot of times, in home station, we've got, high bandwidth, optical fiber networks. We have a lot of bandwidth. It's very stable, where it's very reliable, but then we extend these capabilities out and away from home station. And of course, we're either relying on something that you can bring, but I heard we were talking like with the G6 of the 82nd, right? He's not going to be bringing a lot with him because he's probably jumping in, kind of thing, versus an airland or other mean of deployment. But when the forces deploy, right, how do we build in resiliency to our networks, right? We talked PACE plan, primary, alternate, contingency, emergency. And how do we ensure that if we're relying on either what we can bring or what is available, right? There's a growing dependence on commercial solutions, which is great, but what do you do when you're downrange and your Starlink terminal goes down or some other, I'll say, commercial solution that you're bringing with you? Ian, if you wanted to start.
Yeah, I'd love to. I think that resilience is not it's not one thing. It's multiple. And so from the Starlink example, first off, Starlink is one commercial SATCOM option. There's multiple others. The problem is you don't have the ability to carry user terminals for every single one of those yet. I think as user terminals start getting smaller and we start doing a lot more direct device, 3GPP work or release 17 and 18 on the 5G side of things, it's going to offer a lot more capabilities in lower swap systems. But thinking about every single side, so having access to 5 different commercial satellite providers, commercial transport. At the user terminal level, making sure that a single user terminal can handle multiple providers and also switching to some sort of line of sight mode or HF mode if possible and when necessary. When you go for every single link, you need it at the hardware and the software level. And then it's not just establishing, we go back to the story I told at the beginning, but with PACE, PACE is not I try this thing for 5 minutes and then if it fails, I move to my alternate, and if it fails, we go to contingency. Instead is I have one-to-N network options based on the nodes, based on the transport, based on the user terminals. If one goes out, that's okay. I've still got one-to-N. One-to-N could be 32 different operations and options that I have available to me. And when you start to do this, what ends up happening is we assume that if something like Starlink goes out, it's because of nefarious activity or near-peer jamming. And that's okay because I have one-to-N. We start seeing that jamming in the spectrum environment. We start seeing weather in the environment. We calculate all of that loss, and we go, we're not even going to try that effort. We're going to move to a completely different system, a completely different hardware terminal. But instead of being very reliant on any single one, hardware, software, or actual transport route. And by the way, I also mean diversity in, LEO, MEO, GEO. We're looking at maneuverable GEO on the Space Force side of things right now. As you start throwing things in cislunar, you want to be able to access it. And so you need to be able to access everything at the same time, and it also goes into the optionality of not just those networks, but of the contracts themselves, because often technically a lot of this is actually feasible. Industry, we've got a lot of great companies here that can provide almost all of these capabilities. A lot of it comes down to business processes or policy within the government on how they purchase or how they acquire, and then how they allow people to use those networks. And so all of the great innovation that we're seeing on the industry and the government side, on the engineering side, being able to partner that innovation with acquisitions innovation and contracting innovation, and then policy, by the way, because we get into a lot of discussions where when you show, and I think a lot of people here have probably showed some really great things to the government that were technically feasible in TRL9 and ready today, and they say, well, that would upset one of my TTPs and one of my SOPs or a policy that I'm not allowed to change, and that causes limitations of accessing some of that really nice engineering as well.
Yeah, that's very consistent with what I mentioned at the beginning, right? Because it's rarely a technical problem. It's almost always a policy problem or some sort of process or procedure kind of thing.
That said, with all the bias that I do acknowledge on having as a software person, software doesn't weight anything, right? So like software solutions don't have to mean exclusively software solutions, but solutions that are heavily biased towards software versus hardware reliability are solutions that you can essentially deploy anywhere, right? Because you don't have the concern. Sure, I mean, they can use more power, but then you keep, as long as you keep it in mind from the design phase, and you design things that work from the edge, efficiently, and how do you get things to work efficiently is by settling for the 70% instead of the 100%, right? So that is easy to do. Like in the industry, we know how to do those things very well. So you can design something that uses a lot of power. You can design something that gets you 80% of the way, doesn't use a lot of power. We were talking about models. Large language models have the same trade-offs. I mean, you can get a model with 70 billion parameters that is incredibly powerful, or you can have a model that works very well on a phone that doesn't use a lot of power, but then allows you to do a lot of other things in software based on that software building block that you used to need hardware for. Right? So every reliability solution that weighs in favor of software versus hardware, when the trade-off exists, sometimes it's clear one or the other, becomes a solution that you can deploy anywhere.
But is it resilient? And I'll say like in a technical environment, right?
Well, I mean, it can be. I think it can made to be because of this. Because again, going back to the building blocks, right? So something that depends on a network to function is less resilient than something that doesn't, right? And something that, but you can make the beautiful thing about software is that you can squeeze it into anything. It's essentially clay, right? So one thing that caught my attention in the keynote is that you have this concern. Okay, so our systems before, I had to get somebody that truly loves America. I'm Canadian, by the way, but I do love America. But you needed to have somebody who truly loves this country to even operate so hard it was. But then you compare this to an iPhone, which is super simple. Now, when I looked at this through time, what I see is essentially this process of turning everything into clay. Right? Before software, like you essentially needed custom hardware for everything. Now with software, you don't need custom hardware for things anymore. And what you're seeing with LLMs is essentially that you can get that person, you can get that soldier on the field to write software, which was something that just wasn't possible 5 years before. If I came here 5 years ago and told you, get the soldier to write software, you would have laughed at my face. Or maybe not to mean that no soldier can write software, but you cannot assume that every single soldier will be able to do this. Look, it's possible now. We're talking in the industry about software solutions that allow people with very little assistance, with very little training, have the building blocks of creating software on the fly. Again, because one of the areas in which you're seeing LLMs be successful the most is in writing software. I have my own theories as to why that is, but like it's just the thing. It's just the thing that's happening. So when you have something that has the building blocks to work offline and has the capacity to be molded like clay in a way that wasn't even possible before. You can have resilient, reliable systems that are more software-based than hardware-based. And then again, the advantage of those is that they can be deployed anywhere.
Yeah, well,
Knew I was going to you next.
well, yeah, well, I was actually thinking about, quite a few things, personal experiences as you were talking about this. And, when we look at resilience in network design, architectural design, whether it's physical or logical, one of the things that I've seen neglected is the other pieces of it, right? It's the people and the processes of the entire, this entire system of systems approach. And that's what we have to do, I think, in order to get to resilient, is take a system of systems approach. And while keeping technology in mind, we need to look at things like communications control, right? If the cyber domain is a battlefield, in fact, in the same way that you are managing a physical battlefield, right, between commanders, and there's areas of interest, areas of influence that are outside of your assigned battle space. Well, the same is also true within the network, right? And so when you have different pieces of the network that are integrated together, my question is do you know the folks to your logical left and right of that network? Do you know what capabilities they have? Do you know what capabilities they can bring to bear to support you? Where are those areas of weakness, where you're supposed to be integrating towards one another? How long does it take you to integrate? And more importantly, who's really in charge of that particular network? Is it the commander on the physical battlefield, or is it somebody inside of communications control center that is providing a critical capability for the commander? So these are some relationship things. As we look at the architecture, we've got to go beyond technology and start looking at it from a system of systems approach.
Yeah, totally agree. Sorry, I didn't have the mic on at the moment. All right, I realize this time goes very quickly. We could probably sit up here for hours, but we would enjoy the conversation. After a while, y'all would be like, all right, let's move on. I want to finish on, hopefully we'll have a chance to get to some Q&A real quick, but I do want to finish on one of my favorite four-letter words, which is requirements. And maybe it's venues like this, maybe there are others. I heard some good conversation during the keynote, but it's like, how do we partner with industry better, right? How does the Army do that, or better, more broadly, the DoD, to improve the requires development in the early stages, right? It becomes a problem. It's too often by the time it gets to RFP, the requirements are either too vague or they're too specific. Industry develops exactly what you asked for, and then you got it, but it's not what you wanted. Now you're unhappy. They're unhappy because they didn't deliver what they thought they were. And we talk about this frequently, and yet we seem to keep repeating the same mistake over and over again. So how does, in this case, the Army unleash industry to basically, and academia for that matter, to basically give them the things that they need, but from a requirements development perspective, as opposed to just, here, let me build you something. It's got to start on the left end and long before we get to an RFP. So, thoughts?
Yeah, I think, when you said requirements, the first thing I thought about is like with a capital R requirements, right? When I was doing
ICDs at one point.
Yeah, I mean, when I was when I did L-class modernization, ships modernization, amphibious ships, with U.S. Fleet Forces Command, it really starts with the requirements writer. Writing the requirements in a way that isn't specking out the industry, right? You want to really talk about what is the capability ultimately that you want at the end of the day, right? It's not the, what's the end state, right? It's getting those.
What's the problem?
Yeah, what's the problem, and what is it we're trying to solve, and trying to stay away from specking out folks. I think that also, if we could operate in an environment where we can, the government could shut folks off that aren't delivering, I think that would be incredibly helpful. Yeah, so I think that those are probably the two key things, how we write our requirements, and then also, you know, I think that the government needs a better off-ramp for folks that just aren't meeting the requirements that were written. No.
Ian?
I got lots of ideas. I'd love to. I could talk about this one all day. I think what ends up happening is often we as industry see requirements that are antithetical to what we're hearing government leaders say, even in the acquisition side of things. We'll hear someone say, I need best of class innovation and new technology, but in the requirements document, you have to have a SCIF and a DD-254 at time of submission. If I'm a brand new company, I just thought of it, 2 weeks ago, I might have TRL9 software or hardware or clay or whatever we want to call it. There's no way I'm going to have a DD-254 at time of submission. And so then the next question is, well, why don't you go and partner with a prime? And there's certain situations where that works well, and I know we've got primes in the room, and there are situations where a prime systems integrator and a small company can do some amazing things together. One issue that often comes up is there are completely different incentive structures. There are different funding mechanisms, there's different runway for each of those companies, there's different risk profiles. A prime that is executing cost-plus labor contracts, time and materials, or cost-plus contracts with someone doing firm fixed price that actually can make more money and higher margins based on the amount of things they've already done in the past, those don't work. By the time the prime is actually moving forward to this contract, they've probably been in capture for 2 years. They've already done an internal business case. They've already mapped out, it's going to be about this big. We think we can build this much profit. They've fought for this much IRAD in order to do it. They're already working at a loss. And so the minute that a small company, an innovative company comes in and tries to partner, they go, we can solve this problem for you, and we need this much work share. And the prime goes, that was never built into my plan. And I can't blame based on a different cost structure, incentive structure, and really business structure. And so those two things don't always work. I think I'm seeing some parts of the government do this thing where they know they need a systems integrator. The government doesn't always do a great job as systems integration because of limitations that they have, but they also don't want the systems integrator to be the middleman in the relationship between the innovative companies. And so instead, they are building IDIQ pools. They're building one of those pool requirements as a systems integrator. That will do all the functions that normal primes do, all of the business case that a normal prime does. However, the government also wants a direct relationship with all of the innovative companies, which we haven't seen a ton of these move forward, 5 years down the road, 10 years down the road, to do the pattern matching to see, was that successful? I can tell you from the small company perspective, it's been hugely helpful for us. And so I think understanding, venues like this to understand some of the limitations that small companies have, that large companies have, some of their desires, and then being able to push through policy in order to remove some of those barriers, it is huge. And so the Army's done a great job, especially through AAL and Army Futures, to do events like this. And then the hope is, and we see it in some of the IDIQs and things that come out, but be able to take all of these, great ideas, and maybe they're great, maybe they're not. I'm up here, so I think it's a great idea, but I don't know. But there's got to be some good ideas in this room, and so making sure that those flow through into requirements documents and acquisition documents. The other thing I'll add, and I know I was talking for a long time on that one, is you had mentioned the clay, and we often see requirements that assume we know exactly what it needs to look like. And there has not been any single war that we've been in where everything that we thought was going to happen beforehand actually happened. That's right. And so if we assume that dynamic warfare is going to be part of the future, we have to build a lot more clay type requirements that kind of is, I think I need 80% of this, but I also need the ability to change the last 20% 10 times in the next 10 years because I have no idea what those 10 years are going to bring, and I need that flexibility in my program.
Well, let me just add this quick. And how many times have we seen reforms to the defense acquisition system and JSIDs, and yet here we are still trying to solve that problem? Go ahead, Glover.
With the caveat that, again, that I do not come from a military background, there are very few situations in our business life in which we're even talking about requirements. If you look about how the startup ecosystem works, like we have a vague idea of what the problem is. And then the question is like, hey, here's some funding that is distributed by venture, solve the problem however you want, and then we'll see what works. So I don't even think I understand, and this is part of the reason why I'm so excited to be here. I don't think we even understand very well in the industry what are the problems that the military has, how valuable each of those problems individually is, because one of the calculations that we have in our minds as an entrepreneur is, okay, I can solve this problem, but how big is the market? Like if I solve this problem, what is the payoff? How much cost can I put in this solution? Because if I put, I can solve the problem at a much higher cost than it delivers, it's a worthless solution. It may have its reasons for not to be this way that I'm not privy to, but one of the ways in which I think this collaboration can happen in a more robust way is for the Army to be talking in the language of the industry a little bit more, which is essentially, hey, look, here are broadly speaking, those are the problems that we have. Should you find a solution for those, here's how you navigate the environment. Like here's how we have, hopefully with a simplified process, how do you sell to us? So I do think that like being less, maybe we're all saying the same thing, which is like be less prescriptive, right? And more descriptive of the problems and not the solution. Don't even talk about requirements. And then you see after the solution is there, like with a couple $1 million, you can test almost every idea, like not all, of course, but like a very broad range of ideas. And then if it works, right?
Well, you bring up a good point because it almost necessitates that industry, pulls somebody from the DoD after they retire and, kind of waves the carrot, pulls them in just so they can navigate that and be successful. And so, is that a good thing or a bad thing? I don't know, but should private industry be able to stand alone and be successful solving DoD's problems without having to pull in, folks from DoD? I don't know. I mean, it's a good question to ask and something that I think we need to ask ourselves as we write the regulations.
Yeah, we don't want to stifle creativity. I think you said it, Glover, maybe it was you. There's a lot of smart people in there. There's a lot of great capability out there, but it can't be I'll know it when I see it, right? It has to be a little bit of stating the problem and then saying, come back and tell me how best to solve this. And I just personally haven't seen a lot of that yet. I'm hoping to see more. Again, I was very optimistic from the keynote, but then again, I heard a lot of stuff that we were trying to fix 20 years ago. Historically, I fielded the first tactical airspace integration system to the 18th Airborne Corps at Fort Liberty. So, and yet it's still a challenge to this day. So, Sam, do we have a minute for? Okay. Oops, okay. I saw first hand go up here. I see a second one going up here.
Hey guys, thanks. It's a great conversation. Good to be here. I just retired from Army Futures Command back in July 22.
Great.
So this stuff is fresh in my mind. The thought that you brought up of bringing somebody from the government side back in, I'm a Marine Corps veteran, so happy belated birthday to you.
That's fun.
I wanted to bring up 2 points. The first one was the resilience aspect of this, and I'll be brief. The resilience depends on a few things, right? We talked about pace. We haven't talked about obfuscation. We haven't talked about steering the enemy down a path where you want them to go to free you up for that resilience, for that pace. And the machine learning aspect of that could greatly improve how you would learn the enemy's things, So it's like when you want to set a trap for somebody, you want to see how they're going to respond to something. Terrorists do this all the time, right? They throw a bomb out there and they see how people, first responders, react, and they go, oh, we kind of figure out how they do things, and now we know what to do next. Well, it's kind of the same thing with electronic warfare in my vision, right? Because I'm a communicator also. Right? So you look at how they respond to things in EW, you steer them down a path. It's kind of like making a rat go where you want them to go and trap them in a bucket, right? That's a little simple process, but that's my thought process, and I'm wondering what your thoughts are on that and how you would employ that from an AI/ML aspect, and then also the obfuscation part to get them to go somewhere else to see how they respond to that, vice versa. And the second thing is maybe there's a think tank or an IPT that we could get together. I know Secretary of the Army just mentioned having faster acceleration of experimentation with industry. We got to move faster. We don't have the liberty to pretend we're in front. We have to pretend we're behind from a fight tonight perspective. So I'd just like to get your thoughts on that across the panel. Thank you.
Yeah, the old fail early, fail often concept, right? All right. Gentlemen?
I've got one thing. I'm not going to solve your problem here, but one thing it makes me think of is, we've had compromises in the past, and the first thing that we want to do is shut the entire network down, right? And I think it really starts with the mindset.
before we look at just putting up impenetrable walls as the solution, I think we need to have a few options. Maybe there's, in the same way that we set up a defense and send out patrols, the purpose is to make contact with the enemy, right? We want to learn a lot about what the enemy's doing out there. And so, maybe that's something we want to do. Maybe that's an option. How, machine learning, artificial intelligence supports that. It's certainly above my pay grade. I don't know the mechanics of how that would work out, but certainly I know that where there's a wire, there's a way, and certainly it can help us. So I don't know if y'all have any thoughts on that.
I mean, most of what we talked about are all the necessary building blocks of what you just said. If you want to, actually throw out and see the entire EW spectrum, you need sensors to do that. You need to have telemetry on everything, on as much of us as possible and as much red as possible, which can be talked about at a higher level. And then you want to do something. You want to try something out. You want to take all the data and pattern match and try to figure out what happened with it. In order to do that, you're going to need a lot of compute and a lot of edge solutions and a lot of different models. You also, and one of the problems I think we run into, or the US government runs into, is in order to do what you just said, there's like 15 different PEOs across the services that are all going to be part of that. And they all have their own priorities and their own things that their bosses have told them to do. And so they don't always match, or the timelines don't always match. And so getting the compute where it needs to be, with the lines, with the resiliency, with the comm architecture, with the AI/ML solutions, all to be ready at the exact same time, and then an area where you can actually test that and mess up the spectrum environment without messing up anything else in the US. It's difficult to get all of that lined up, and so we often see mismatches there.
Don't have anything.
That's okay. I just want to give you that option because I want to make sure. Yeah, I think we had one other question over here. Did we? All right.
So we have an internal philosophical coding question, and I'd like to hear your opinions on this in terms of resiliency. First of all, thank you for your machine learning versus linear and fractal regressions. That's a great joke. But just like our human body is able to be resilient against 1,000 different attacks that come from us, airborne, from all kinds of things, in the system of systems approach, what are you thinking, and what are your thoughts about machine learning and AI becoming the viruses that are attacking these systems, and how to be resilient? Because it's a lot easier to go attack with a virus than it is to build a system that can maintain against 1 million different attacks. What's the thought about that?
Well, look, I think first of all, this analogy between the human body and computer systems is something that we've been using for a long time because it is very useful, right? It's just when you look at the human body as a machine, the fact that it works the way it works with so little resources. And so there's a lot to learn there. And I do think that the most important lessons are exactly the ones that we've been talking about here today. We talk about edge compute for a while as a way to improve resiliency, as a way, for example, to have those things functioning offline. It's exactly how the human body does most of those functions, right? Because there is a virus, it takes over. But then what tends to happen is that it takes over subsystems of your body, right? Exactly because of this. Imagine if every single function in your body dependent on central control, like the impact of that virus essentially to kill you first glance, because if it shuts down that one system. Now, of course, we do have systems that are more important than others, and then what happens is they are more protected than others. That will be a very inefficient way to build a human body by making this incredibly shared thing that is incredibly protected. So what you have is you have systems that are less important for the functioning of your body, but they're still important for the whole. You hope that they work, right? But the intelligence, quote unquote, to operate them there at the edge. You don't need your attention to breathe. I hope so. Those are things like that. Things that operate independently, things that operate with the data that they need. So the data to operate your body is in every single cell of your body, right? It works offline in a sense. Like you don't need attention to replicate your DNA. You don't need any of that. So the lessons are there, and then the question is, of course, the practicality to move that into a system. But ultimately, I think that every solution that starts from how do we defend against that virus, and if we don't, it's the end. It's a bad solution. It has to be how do we defend against it,
What are the systems that we truly need to defend against it? But let's assume we don't, because let's assume it will go through, right? Then what keeps working, what doesn't work, and where do we go from there?
I think we're going to see just a mix of tactics and counter tactics constantly changing. The most recent example is the drone example that we're seeing in the Ukraine. We're seeing this on the EW side in the Ukraine as well. As you start looking at proprietary waveforms and artificial intelligence generated waveforms, something that can look at the spectrum, can understand what everything looks like, and can understand your thoughts and needs of, let me build something that is one waveform that I'm just going to use today. Right now, it's really difficult to see and to intercept that waveform. Over time, there'll be another adversarial network on the other side that can say, I need less data in order to actually see that network. And then all of a sudden, we have to do it again, and we have to be even faster and do it with less information. And so this tactic and counter tactic of my artificial intelligence algorithm doing its thing, this other one trying to make it better, whether that's on our side trying to make it better, an enemy, you're just going to see it going back and forth, and it'll just happen faster with less swap and more often is my guess.
Yeah, as far as machine learning and artificial intelligence, getting down to the brass tacks of, how to make it work and how to support resilience, I think that, before you can answer that, you really have to get down to, again, the people and the processes piece of this. I mean, at the end of the day, everything that we're doing in technology supports some physical, real thing that's downrange, right? And so the ability to prioritize that first, I think that's what we need to do a better job of, so that way we can inform that AI as it's being built on what actually does need to be protected, right? I think that if we kind of take that approach first, how we're supported by AI and machine learning is probably going to be a better outcome. So I hope that answers your question. Yeah.
Great. Well, I appreciate everybody's participation. Thank you for being patient. I know we just went a little bit over. Thank you for that. Thank you to the Army Applications Laboratory and Army Futures Command for hosting us and allowing us to have this conversation with you all. And I will also take a moment to thank my panelists here. Thank you all for your time. I appreciate it. And some of the pre-conversations that we had and a little bit of data sharing back and forth. But also just an opportunity, as I always like to try to take. Thank you to all the active duty folks and to our veterans. Thank you for your service. Thank you for continuing service for those that are still in active duty. But also let me say thank you to all of the folks that are not in or have not been in uniform that contribute to the keeping our Army and our military world class. It's a fight we all work on together, whether you're in uniform or not. And because you're here, you show an interest in keeping the Army world class. And so thank you all for that as well. And so appreciate your time. Sam?
It was a great panel. It's really important, our partnership with the Army, with the industry, and always to hear industry's voice to help us get after the problems that we have in the Army and find those right solutions. A couple announcements before we kick you guys off. At 2:30, your breakout sessions will begin. And these will be unclassified discussions. It'll be like workout sessions, and navigate to the breakout location that you think best emphasizes your expertise. You'll be able to provide the most feedback to us as the Army. So we're going to be gathering data, collecting it, and then aggregating that data after this to see, hey, where is industry telling we need to point that north needle? You can use this QR code right here, and it'll provide all that information on the back of your, where the locations are on the back of your name tag. Next slide. Hey, lunch. Lunch is on your own. Enjoy Austin. There's great locations. You got about 2 hours for this. This QR code right here is our contact network list. So this QR code will also be on the front entrance of the Voltron room, and you provide your information, we'll give you access to the network of folks in here. And tomorrow we'll be providing a box lunch and a salad. Many of these VERTEX events companies have created partnerships. Some companies have even been acquired by bigger companies being these things. So tomorrow we will be providing you a box lunch, a salad, for you guys to hang around here, network, sit in the rooms and the multiple floors upstairs. Next slide. Here's your breakout locations. Like I said, on the first floor, in this room, around the kitchen over here, and then on the 8th floor. There'll be a map, and there'll be folks from Army Applications Lab showing you and pointing you where those locations are. And remember, those are unclassified discussions. Next slide, and most importantly, Higbees. My favorite part of all these events is the networking and social aspect of these things. Higbees, if you walk outside these doors, right across the street, that's where it'll be. And so make sure your moderators in your workshops don't keep it too long, so then we can get to the most important and funnest part of the VERTEX event, is the networking social. So, ladies and gentlemen, thank you for this morning, and we'll see you guys tomorrow morning after your breakout and after the network here at 9. Thank you.